Thought you'd sent your cat there, Brian, for the session. You were out of view as it wandered past.
Colleague Fergus the cat, but he probably won't be sitting in on the meeting later on when it's my talk.
Stu, did you see, Stuart, did you see that Melanie is having transport issues? So it looks like, there's going to be a change in the program a bit.
Okay. Is that
but
on?
I am
Oh,
here.
you're there. Hello.
I am here, so I'll be able to hear what you're saying, Stu, but I'll be in an Uber. So I couldn't get an Uber this morning. It was completely impossible. So I've got one booked and it's going to pick me up in 3 minutes. So I'm going to listen to you in the Uber and then Luke will talk and then I'll get into the building and give my talk.
All right. Sounds good. Okay, so who is chairing this morning?
So as far as I understand, we've decided that we don't really need to chair it too much because it's mostly the operations team.
All right.
Yes. So I was going to do that when I get to the office. Obviously, I'm not going to do it right now. So maybe, Stu, if you could just sort of try and keep yourself in check.
I'll try and keep myself in check. You know,
You're good at that. You're good
I like
at
to talk for a long time, as you know.
Yep.
All right. So you reckon your Uber ride is going to be about 20 minutes then?
Yep, I reckon. So I'll listen.
Swinging into action after that.
Yep. So, but feel free to go ahead. I can hear you from the Uber.
All right. Sounds good. Well, I think we'll wait till the DNDT drops a bit. And then we'll make a start. Okay. All right. I will head off then. So, hello everyone. So I think as all of you know, it's customary in Australia to further the development of how respectful relationships with Indigenous Australians through acknowledging that we're on lands for which they've been custodians for thousands of years. And so today we're all in a number of different places, I think both in Australia and overseas. So I'd like to begin by acknowledging that I'm attending from the lands of the Wurundjeri people and pay my respects to their elders past and present and emerging, and also specifically acknowledge the Wurundjeri people as traditional owners of the MRO site and pay respects to their elders past and present and emerging also. For those of you I haven't met, I don't see too many unfamiliar names on the screen, but I'm Stuart Wyeth. I'm from the University of Melbourne and have been chairing the board in 2020. Like you all, I think I was looking forward to being in the Netherlands. I still haven't visited the Netherlands at this late stage of my career, so I was looking forward to that. But I thank Melanie and the team for suggesting that we have this project meeting in its place. It's important for us to to get together, stay up to date with the progress that continues to be made with the MWA. So thanks to the team for organising, and thanks to you all for making the effort to attend. So we had the board meeting earlier this week and discussed a range of issues, and these included the exciting topics of the next phase of development to enhance capacity for the MWA. And I'm not going to try and summarise that here. The team will be talking in detail about the various aspects of the future development for the MWA, as well as its current status. But I would like to take the opportunity to, on behalf of the board and the project, to thank the management team for their ongoing commitment to the MWA, which has been enabling this science to continue, and for their efforts in developing the next phases of capability. So I will wait till, I want to say a few words about Melanie, but I'm going to wait till she arrives in the building to do that. So we'll without our change of order. So I'm going to, I'll act as the chair until Melanie gets here and pass to the project scientist to take us through the first talk of the day.
Cool, sounds good. Okay, I'm just gonna share my screen so I can start presenting. A second. From Zoom is, yeah, all of the different screens. Cool, hang on. Okay, yeah, you guys can all see the PowerPoint slides.
Yeah, that's good.
Cool. Yeah, okay, so hi everyone, welcome to this virtual project meeting. I'm going to be giving a principal scientist update. This is going to be consisting of just like a brief, summary of, how things have gone this year in terms of, the TAC and so on. And then I'm going to be sharing some slides that I got from the science leads. I couldn't include everything that the science leads gave me because, I mean, there's a lot of science that's been done this year, and a lot of it is interesting. So it was hard to distill everything and curate it, but I made an attempt. Also, I might miss out on getting across some of the important details or interesting details. But I suggest that, if you're interested in some of the things that you see that I don't, communicate very well or get across, everything that I'd like to, check the papers out or contact, the science leads or the science groups. So I'm just going to quickly, briefly cover, some stuff that's happened, with the papers. So citation rates are increasing. This is, citations per year, which is quite good. So the top plot here you see is collaboration papers. And at the bottom, you see external and public papers. And so this year there were about 1.4 thousand citations. And for the public papers, there were about 300 citations. And you can see this has kind of been increasing, quite a lot with each year. So each year we've been getting more citations than the previous year. And I would say that, if you look at the collaboration papers, maybe like 4 years ago, or maybe, yeah, but maybe like 3 to 2 years ago, the public papers are at that kind of stage. So I wouldn't be surprised if in the future we see that this, this curve looks very similar to where the collaboration papers are now in terms of citation rate. Here you can see that there were 11 collaboration papers accepted this year, and there were 17 using external or just public papers. In terms of total citations up to 2020, yeah, again, the citation rate is increasing, but that means that now we've got to a point where the total collaboration citations are on the order of 7,000. And the total public citations is on the order of 1,000. And there are about 140 collaboration papers to date. and there are about 75 public papers. So I think this is all really good news, because it shows, people are really, still like citing the MWA, and, in fact, they're citing it more and more each year. And that's probably tied to, the more papers, and, the more, it shows that the MWA is kind of leaving an impact. So yeah, in terms of papers this year, one thing I wanted to point out, so there were living collaboration papers, and there were 17 external public papers. So now you can see that the external and public papers are increasing, and there were more of these than the collaboration papers. And the MWA has matured to a point where there are, exciting public data papers. So yeah, it's really kind of coming into its own as, a telescope where, people outside the collaboration, or not necessarily, I mean, some of these people were publishing public papers in the collaboration, but, you're actually getting more variety, with people doing work that's not within the collaboration itself. Which I think is cool. And one example of this, one of these examples was this paper that I'm actually going to be talking about a little bit later, where there was this cavity generated from some kind of explosion in a galaxy cluster, and you've got the intercluster medium, and there was this created a lot of noise in the press, is something exciting, and that that got a lot of notice, and it was actually from an external paper. So there are a lot of exciting papers that are external ones, and it'd be cool to keep track of who's doing these things, even if they're not in the collaboration. So something else that I wanted to make everyone aware of is that I'm currently kind of going over the wiki publication list. And then I'm going to be updating the website again in terms of making sure it's all up to date, the publication list on the website. And one thing I started to notice is that, some of I wanted to check with people if their papers are recorded correctly on the wiki, so that then they can be, made sure that they're consistent with the website. And this is for external and collaboration papers. And also there are some paper proposals from quite a long time ago, like some of them are like 5 to 7 years old, and it looks like nothing really happened with them. And so if this is your proposal, or you're involved in it and it needs to be withdrawn, please let me know. I might have to kind of reach out to these people and find out what's happened. And some of these papers, are so out of date that's, someone else or a group of other people have published effectively the same kind of result in a different study. So this kind of needs to be cleaned up. And the website will soon be made consistent with the wiki, and that will be happening, in the next few weeks. The time assignment committee. So there's not much to really say here. Everyone got their time assigned from the last for the last semester. So now I'm going to move along to talking about actual science. So now I'm going to be giving the SHI update. So SHI has really been focusing on this type of emission that's weak non-thermal emissions from the sun. And I think it's quite exciting because it really takes advantage of the MWA having high dynamic range spectroscopic snapshot imaging. And it also is taking advantage of their imaging pipeline that they've developed within the group. And the two types of weak non-thermal emissions that they've been focusing on are from coronal mass ejections, so CMEs, and you get a type of emission that you can see that comes along with them called gyrosynchrotron emission, which is from, let's say, charged particles trapped within the CME, causing a synchrotron type emission. And the thing is that there's only actually been a handful of these CME gyrosynchrotron emission events actually detected since like 2001. but this, this high dynamic range spectroscopic snapshot imaging pipeline that's been developed is actually starting to make it maybe possible to do in a routine way, where you can actually study the science of these things in a routine way. So I think that's quite cool, to take something that's barely been detected and start to make it into more routine science. The other thing, these weak impulsive narrowband quiet sun emissions, which were first proposed as a possibility and have now started to be detected much more recently for the first time. So here you can see a CME from the sun, and here you see there are these three circles, and within these three these different regions, you can see the spectra, the synchrotron-like spectra within each of these regions of the CME, which you would expect from gyrosynchrotron emission, and this actually goes quite far out from the sun itself, which is quite cool. If I remember right, it's it's actually detecting quite far out from the sun than the previous detections. And if these green circles here, they're 3 and 4 sun radii. So these are the most detailed, spatially resolved observations of gyrosynchrotron emission from CME plasma yet. They're the deepest observations and detection at the largest heliocentric distances. So that's, these distances going really far out. There is evidence for low filling factor of thermal electrons. So this gives you an idea of how we can actually learn about the gyrosynchrotron emission and how it's the electrons that it's being produced, that are producing it. And one of the cool things about this is this shows, this is kind of like a demonstration that there is ability to do detailed modeling for something that is, otherwise not a very special CME, which means that the imaging quality provided by the MWA and the pipeline developed can be done routinely. So that's quite cool, because that means that you can actually do a whole bunch of science routinely that you couldn't do before. Again, just very briefly, here are 2 simultaneous CMEs from the sun. There's a north one and a western one. The north one model in terms of spectra. The western one, the spectral shape is not consistent with gyrosynchrotron emission from a single plasma electron population, which suggests that maybe there's a more complicated scenario. Maybe there's multiple electron populations or something else going on. And this, this kind of it verifies that it can now be used as a routine tool for CME investigations. And so this is for a paper that's in preparation. Just to make sure I don't take too long on this, there's a lot to say for Shai. These weak impulsive narrowband quiet sun emissions. Here you can see probabilities of occurrence within, taken over each of these point spread function sized regions. And you can see here's the flux and the probability. And note here, this is a log scale, which kind of demonstrates something about the high dynamic range that you need. This crosses many orders of magnitude. The first key takeaways from this is first, direct detection of impulsive non-thermal emissions from quiet sun regions, and it explores at least 2 magnitudes weaker features than ever seen before. And they all satisfy the criterion for being relevant for coronal heating, and tantalizing indirect evidence for nanoflare-based coronal heating. And for those people who don't really know much or don't do much to do with solar physics. This coronal heating problem is like a famous problem that everyone is trying to understand, and people are spending, hundreds of millions of, dollars in different currencies to try and understand this problem, building stuff to send into space. So I think it's quite cool that the MWA is actually making progress on something like this. Very quickly, I'm not going to spend too long on the slide because I'm taking longer than I expected. But AI and machine learning methods have been used to, search through a lot of data, 85,000 images, to try and characterize these weak, impulsive, narrow band, quiet sun emissions. And you can also try to understand the properties of these, the morphological characterization of these emissions and so on with these methods. So that should hopefully lead to a lot more science. So now I'm going to quickly go into the transient update. So first off, here the MWA has been used to look at follow-ups of gamma ray burst observations for FRB-like emission. So the idea is, there's an FRB and, there's a gamma ray burst, and you try to see if there's a FRB emission, so fast radio burst emission, that follows it or something similar to it. And they have achieved the most constraining limits on the radio emission following gamma ray burst at this point. And the thing is that the MWA has the best sensitivity and instrumental response combination to search for early time radio emission. And you can see more about this in this paper that will be coming soon to the collaboration. And yeah, here you can see a plot of these upper limits and sensitivity here compared with some other telescopes. So another thing that the transient group has been looking at is follow-up of neutrino transient candidates. Since September 2020, so that's, I guess, only a few months ago, the VO event trigger system has been in place to trigger on neutrino events. In the last 2 months, the MWA has triggered on 3 neutrino events from the IceCube Observatory. And 2 of these triggers are quite interesting. One of the triggers is consistent with swift observation of a Fermi source, and the other is a high quality reconstructed neutrino event. The transient group is currently migrating the code that they have from Zeus to Garawala to analyze the data from these observations. So hopefully we hear a bit more about this in the future. And also something else that the transient group has kind of been looking at is space situational awareness. So the basic idea is, observe in the FM band, and don't flag the RFI. And then you look for the RFI that's reflected from the satellite debris. In other words, satellite and debris, so stuff that's in space. We have, so the transient group have detected many objects in low Earth orbit. Here is an image of the International Space Station streaking through the sky, as you can see here. And see this paper that was published this year for more details. There are many new observations during Space Fest, including a re-entry capsule, which is quite cool. And yeah, stay tuned for more results. This sounds kind of interesting and fun. So now I'm going to be moving on to the EOR side of things. There was a lot of slides for EOR, so it was really difficult to curate this. But hopefully I've managed to get across the broad ideas here. Yeah, the basic idea of EOR is to search for hydrogen at redshifts of greater than 6. And the EOR group has has been working on a lot of different things to work to a common cause. So we've had, simulations where we've got Woden, the GPU accelerated all sky simulator with the MWA beam, point sources, shapelets, and Gaussians. So that allows us to create models of the sky. And also, I think, if I remember correctly, the stuff to do with the instrument. And we've also got cross-pipeline validation for the EOR pipelines, which is actually very important in terms of understanding what's happening with the different pipelines. Also, we've got the stuff to do with understanding the instrument. So we've got the MWA in situ beam measurements, from the ORCOM satellite transmissions. We've also got understanding of the impact of not understanding elements of our instrument or sky model for calibration and obtaining a power spectrum. And we've also got Van Vleck and corrections for quantization noise from from like the correlator, and which should help improve smoothness. And we've also got stuff to do with the sky model. We've got the lobes point and double source survey that's being worked on. We're getting improved models for the diffuse sky, and we've got M mode large scale reconstructions to get reconstruct the large scale diffuse emission in the sky as well using M mode analysis. Also, something that's kind of difficult and important to do at low frequencies is simulating the ionospheric activity to understand its impact on, EOR observations and the effect of chromatic supernova remnants in EOR too. I think this is supernova remnants. So, and I'm going to be quickly talking about this now. There's new upper limits. There have been new upper limits this year for all of the 3 EOR fields for different redshift ranges, from the observations from 2013 to 2017. There's new upper limits for 14 hours for EOR1 field, and this is using, a new model of WINQSE, improved RTS calibration, improved RFI cleaning. And I believe that this makes a big difference, and this is going to be coming in the future as a paper. And also there's new upper limits for ultra low frequency, edges band analysis, which also sounds very interesting. As I was just to kind of get back what I was talking about before, the EOR team is looking at different things to then combine, the modeling the sky, modeling the instrument, direction-dependent calibration. Then you calibrate and peel, and then you can do the analysis. So the team is working on all of these things individually to end up with upper limit results. And the MWA results in MWA data results in new statistics here. So very briefly, what you see here is there are new upper limits using tons of data. So 35 terabytes of data goes into each of these lines. And in fact, here you see that with some of these new upper limits, it's the largest data collection published from any EOR experiment, 450 hours, 3 fields, multiple different red shifts, and the deepest limit from 110 hours of data. And some of this will be improved in the future with the study here. Let's see, here you can see the different redshift ranges where we've got different upper limits on the power spectra. I think that's the most important thing to say about that. But one thing that, in terms of the broad picture, that all of this work that the EOR team is doing there are a few things to say. First is the MWA is one of 2 telescopes that is currently actually putting limits actively on the EOR. They're all, other telescopes are currently not doing it or not in operation, except for LOFA. And this work this work that this team has been doing, the MWA EOR team has been doing, is actually, the last like 3 years has actually push down the limits by multiple orders of magnitude. And this is what this plot is showing. It's showing that, I'm getting improvement understanding of the instrument and, sky model and the pipelines has really improved, our ability to put limits on. And I think that's quite exciting. And I want to see, I'm looking forward to seeing what the next results are. So now I'm going to quickly talk about GEG. I need to keep track of time, hopefully not going too over time. So the GEG has been publishing in a bunch of different areas. So we've got POGs from Risley et al. So that's to do with polarization at low frequencies and rotation measure, so understanding cosmic magnetic fields. And we've got, radio galaxies and looking at, these kind, understanding, extragalactic stuff. And then we've got, looking at the Magellanic Cloud and nearby galaxies. And we've got studies of spectral lines, so understanding, chemistry and molecular stuff in space. But we've also got SETI here, which I think is pretty cool, looking at the Vela region to, put constraints on extraterrestrial life or intelligence more generally. And then we've also got stuff from cosmic web and clusters. So, looking for diffuse, non-thermal emission and understanding it within galaxy clusters, and also just looking at, different candidates for sources, low frequency sources, large scale synchrotron emission in the sky. So one paper that I'm going to highlight is one that just recently got accepted, I think in the last few weeks. So this is looking at the spectral variability of radio sources at low frequencies. So the basic idea is that when you see spectral variability in radio sources, especially at low frequencies, it encodes information about how this emission has either the emission process or how the emission has been, is probing the intervening medium, so the environment that the emission is passing through. And this study shows the largest, it's actually the largest study of spectral variability of radio sources to date. And in fact, if I remember right, the method shows a new way, the paper shows a new method to actually find these things, and to, that's quite useful, because the more you find, the more that you can actually understand about how, spectral variability, relates to the environment, maybe actually understand what causes it. So I think, that's quite cool, because people currently don't know a lot about these things. So now I'm gonna be talking about the VCS side of things, and so this is like pulsars. So here you can see that recently, this year, the VCS team has been looking at polyphase bank polyfilter PBF inversion. So the basic idea is that when your signal is taken from the instrument and it's averaged in time and frequency, there's the averaging process, which is generally done by it's a filtering process, and so this is gets tied into your instrumental response, and this puts the resolution limit on the signal that you see for your voltages and intensity. And the basic idea is that with this inversion process, we can actually try to undo it, just as you would try to undo the averaging process of something like a point spread function. And by doing this, it allows the VCS team to improve their time resolution. So here you can see the original resolution was on the order of 100 microseconds, and here it's been taken down or increased to 0.78 microseconds. So this is quite a big improvement by inverting this process with the method that they've developed. And the reconstruction error is on the order of 0.5 dB, which is seriously small. So I think it's pretty good in terms of what's happening there. So that's quite exciting, because it means that now they can actually start to do more science with the MWA, because before they could only study on the order of second pulsars, period pulsars, and now this allows them to actually go down into millisecond pulsar territory with the MWA. And that also allows them to get more accurate timing that can maybe allow them to start studying pulsars for, pulsar timing array experiments, where maybe they're trying to understand, trying to detect things like gravitational waves with this pulsar timing array. And you can see here that they've improved the resolution, and the emission looks very cool at high resolution at low frequencies. It's actually probably not very easy to do this, even in general, and that's my opinion at least. And the other cool thing that you guys might have seen recently, in terms of there was a paper proposal sent about it recently. There's the first new pulsar detected with the MWA. And this was done as a part of this ongoing survey that they've got, going through all of the data. It sounds like a lot of data, and there's enough data that it looks like they could probably find a few more pulsars. So 5% of the sky searched to 1/3 sensitivity. This pulsar has a period of about 1 second. The DM is not very remarkable, but that's cool. But it actually stretches out the signal quite a bit in time. So this is the de-dispersed signal that you see here. You also see it doesn't have too much scattering. They also, once they detected the pulsar, they could go back through the data and look at archival data and actually get more information about it. And here you can see the flux and arbitrary units plotted as a function of time. And it looks like it has large variability. And they also did follow up with Parks and GMRT to get more information about it. So I think this is cool to actually see the MWA starting to discover new pulsars, and that can maybe lead to more understanding of what these these slower pulsars look like at low frequencies. So now I'm getting towards the end, so hopefully I'm not going too much over time or anything. I'm going to be talking about just the media updates. So there was a media release for the SETI survey of the Vila region, and this was cool, and it got quite a lot of attention. You can see that there were 176 news outlets that looked at this. And people were tweeting about it, and so it's giving the MWA attention, which is quite cool. I think it's cool because I've never really heard of a survey like this that looks at different regions of the Milky Way and tries to put constraints on looking at finding extraterrestrial life. So I think it's cool, a good idea. One of the last things I'm going to be talking about here is that there was a media release relating to this, the biggest explosion in the history of the universe. This was done from a public paper, which also includes Melanie, but the authors were also at NRL and NASA. And it ended up being the most successful media release in the history of ICRA. And the basic idea is that this cavity here it had to be generated by an explosion of some type or shock that was one of the largest in the history of the universe. And this is in a galaxy cluster here, so these scales are huge. This is the Anticosta medium, and so it's pushing quite a bit of mass back over a large region. It reached a potential audience of 2.7 billion people from the media release, and I believe Melanie had to do TV interviews with BBC and Al Jazeera, plus some international radio interviews. There were about 1,200 articles from news outlets that mention ICRA, and about 1,500 news outlets that mention the MWA during the period of the release. The majority of the media coverage occurred in the UK. I believe it was a Daily Mail article that was the most popular, that reached the most people, which surprised me a bit. You know, I don't really think of them as a science thing. And I think Australia was like 10th in terms of the media coverage on this list. And something to do with I think there's a good reason for that, apparently, to do with how Australia, the Australian media works. And yeah, quick summary. I don't know if I've got much time to go over all of this, but yeah, I think maybe I could leave it here if I'm going over time.
Thanks heaps, Luke. That was a really great summary of so much good work going on across the MWA lately. We've got time if anyone has a quick question for Luke. While I can see Melanie on the screen there now, so while we're waiting for her to sort itself out, just ask if there's any quick questions for Luke.
Or if anyone wants to clarify anything, like one of the science leads or something like that.
And you can use the electronic hand or sing out. There's not so many of us. Okay. Well, thanks again, Luke. That was really nice to hear such a diverse range of topics and science and the exciting media coverage.
Cool.
Okay. So we'll come back to Melanie's. I think I'm on screen. Yeah, we'll come back to Melanie to provide her director's report. But just before we do that, I wanted to take the opportunity on behalf of the board and the wider project to thank Melanie for the enormous contribution she's made to the MWA. As you all know, she's been a mainstay for a long time. The past 9 years as a board member, board chair, and the director, of course, most recently. But this week marks her last project and board meeting as a member of the board or the management. And so I was pleased to see the schedule's got an opportunity for her to provide a retrospective on the changes in the project and the telescope over that long time. Of course, she's a prolific scientist with the telescope, and so we hope that she'll continue to be involved in the project in that way. And wish her luck as she moves into her new leadership role at Curtin. But this is a significant occasion, and to mark it, we wanted to provide Melanie with a token of appreciation from the project for the many years of work she's given. And so Mia has a gift for Melanie on behalf of the board and the project, which I hope she'll accept with as a token of our gratitude for all the work that she has been doing.
It's not a story.
Virtually.
Stab people.
No, but we wanted something slightly more, maybe different than what you might.
Ah,
So there you go.
that's very, very cool.
You
We
see
should
it in the
show
camera.
people.
It's a photo of the galactic center taken by, well, not a photo, but data from one of Melanie's students.
Postdocs. Yeah, that was processed by Luke Heinzen with the phase 1 data. So thank you. That's super cool. Yeah, no, that's very, very cool. Thank you very much for that. Yeah, so I am going to, and thank you, Stu, for the words of thanks. I am going to talk later on about my 9 years in the MWA, so I won't do that now. I will just move into the director's report and come back to 9 years of the MWA later. So, right, how do I make this go? I have to share my screen here, Mia?
Yep.
That one. All right, can you all see that? And can I just say that the fact that this is all functioning well and the MWA is adapting to the fact that I couldn't get an Uber this morning is a hallmark of 2020 and the team's ability to respond to anything that's thrown at them. So everything here is working flawlessly, and even I managed to listen to Luke's talk in the Uber. So there we go. Right, how do I make this advance? There we go. All right, so I want to start with good news. So the new MWA NCRIS operating contract between Curtin and AL was executed on the 17th of November. This is the contract under which MWA operations will happen going forward. So this is a a contract that replaces the previous one that we've had in place since 2013, and it's a much more flexible legal instrument. And so it's more streamlined, allows money to come in not just for operations, but also special projects. The first of these, I am delighted to say, is the funding of the MWACS correlator, for which we have now received $1 million from WINQSE via AAL. So that was actually executed as a project under the new funding contract or operations contract. And we've sent an invoice out for the first $400,000. So MWACS is now fully funded. And yeah, that's super exciting. And AAL have confirmed that they're on track to finalise the next 2 years of MWA operational funding from the Australian side. So that'll be the financial year 2021 and 2022, and 2022 and 2023. So, and the funding level is very likely to remain at the level that we're currently at of 1.495 million per annum. So this is good news. Those of you who have seen my director's updates will know that I often start them with "show me the money," and so it's good to actually have the money. So here, show you the money. So on the new correlator, I'm not going to talk a lot in detail about the correlator. I believe Brian is going to cover that, and Mia May will cover the schedule in her presentation. What I want to talk about is the work that's gone into it, just to highlight to the members of the collaboration how much work the correlator team have done and the long road that we've been on towards this MWACS correlator. So back in 2018, when I was in my first year as director, having transitioned from chair of the board, there was a discussion about, now that we're in phase 2, what's next, and what would be the first thing that should be upgraded as we go forward. And Randall, as principal engineer, was asked to put forward an upgrades option paper, which he did. And Adam Beardsley then convened a science review panel to look at that and to talk about which of those things were most scientifically interesting. And on the basis of that, I put a recommendation to the board that a new correlator was the first thing that should happen. Not only does it de-risk the legacy correlator, which has been in the field since January 2012, but it puts us on the path to a fully 256T MWA system for phase 3. And so that was accepted. And then Ian Morrison, Brian Cross and Greg Sleep started working on a design. I put in a funding application in May 2019. That's the one that we've just got. So it's been 18 months to get the funding through. And I also want to thank our partners in the US who also tried to get funding for the correlator in 2019 through mechanisms in the US. And ultimately that wasn't successful, but fortunately AL have come through. So in 2020, we were advised in the middle of the year that we were likely to get the money, but it was still being looked at by the minister, and that it had been shortlisted by AL as one of 2 projects to put forward for special additional NCRIS funding above and beyond what's normally put forward by AL for the astronomical community in Australia for operating instruments. And so on the basis of that, Mia worked up a project plan from July, and we thought we were going to get the money imminently. And as you know, we didn't get it for 6 months, but we stuck to that project plan. And an enormous amount of documentation has been produced by the team in the latter part of 2020 in support of this. So I'm not going to go through all of those listed documents there, but that's the set of documents that were written in support of the correlated design process and finalization and getting all the milestones and things in place. So I am going to thank these people, which is the correlated team, and I stole this slide from Mia. So it's much more nicely put together than it would have been if I had done it. So these are the people who are responsible primarily for the work that's gone into MWACS, with the supporting roles by Andy McPhail and Dave Emmerich for how to install and deploy the system. And we are on track, and I think Mira will talk about this later, for the deployment of the system in early 2021. So you can thank these people, buy them a beer when you see them next, if you plan to use the MWACS correlator in the future. So Mia's going to talk about this schedule, so I've stolen that from her as well, so I'm not going to talk about it, except I want to highlight this, that we had on that a critical design review, and that actually happened on Tuesday this week. So we met with the design panel, which was chaired by Adam Deller, and contained Chris Phillips from CSIRO and Chris Brockemar from Astron. So Adam Deller, if you don't know him, is from Swinburne. And the team that went very well, and the team have now responded to over 90 OARs to answer for the CDR. And I think as of this morning, we've signed them all off. Is that right? Are there no more questions? Are we good? We think so. So that's been really successful, and I just wanted to sort of highlight how much work had gone into it. And when I come back and do my retrospective on the first MWA correlator, you'll see it's a very different process. So this has been a significant amount of work, and I think the team have performed admirably. All right, now the important thing is for the science collaboration is that this means that phase 3 will commence. So with the delivery of the MWACS funding and the installation of the correlator next year, we will be on schedule to proceed to phase 3, which is due to start in July 2021. So this will conclude phase 2, which commenced under Randall's tenure as director, and we had an opening in April 2018, which is one of the first things I did when I was director. So hopefully there'll be an opening for phase 3 next year sometime. And phase 3 was previously defined by the board last December to be a 5-year operation and upgrade phase of the telescope to run from the mid of 2021. Now, whether or not it stays like that depends on how much money the board will raise over the next 6 to 12 months, and Stu will have to work hard on that. But I think it's very optimistic for where we're going at the moment. So that's exciting. So it's always good to end your tenure as a director on good news. All right. Now, I want to talk about what this means for semester 2021A. So that table that you see there is our current contractual milestones with AAL for operation of the MWA. The 2 sets of dates are the original dates and the ones that we've currently got after a variation to contract. So we are contractually obligated to run a call for proposals for 2021A. However, this is obviously in the period where MWACS is going to be installed and commissioned. So what we will do is I will put out a call for proposals probably early next week. And this will be for a limited observing term in May and June for shared risk observations and for technically experienced MWA teams. So this will be an opportunity for people to help do the scientific commissioning of the correlator and help debug the system. So if you want to get first access to the new MWACS correlator data and you are a experienced member of the MWA, then please respond to the call. If not, maybe wait for them to debug it. But so that's the current plan. And then from the second half of next year, we will hopefully have a fully functional and debugged correlator ready for science use. All right. Pawsey, I just want to give the collaboration a quick update on Pawsey. We've had some IO tape issues with Pawsey. Greg is going to give an update on the archive and the situation with the archive in his talk. So I won't go into that much detail. Suffice to say that we were running out of space. And so Pawsey have procured some more tape, which they've installed. So we should be okay for the remainder of our observations for 2020B, which runs till the 29th of January. Greg has been amazing at actively monitoring what's going on in terms of data going in and out of the archive and making sure that we don't get into a situation where we can't ingest new data. It's been a heroic manual effort on Greg's part. This leads on to the data lifecycle policy, which I think the collaboration is aware we had to come up with for the first time because we had started to fill the archive. And so the policy was approved by the board. It's on the MWA website if you want to have a look at it. It went through a science consultation process since the last project meeting where we had some discussion and questions about it from the collaboration. And Harry and Greg are in the process of implementing it. And I think Harry's probably going to talk about that mostly today. And Harry and Greg and I have met and ironed out some of the edge cases. So they've now got, I think, sufficient information to go forward with that. And I set a date of March as the first rollout instance. And then there'll be a future capability added later on. And Harry will talk about that and how that's going to work and the mechanics for the science collaboration. One thing, again, that I want to highlight is that this is a process whereby we've had to think about how you manage data, not in just a linear timestamp type way. So it's not just the conveyor belt of timestamps determine the value of data. How do you actually curate data which is valuable for other scientific purposes? And I think this is a considerably more advanced system than any other telescope has got. And so this is an example of MWA really, again, being a precursor or pathfinder for telescopes of the future. And so I think the thinking that's done by Harry and Greg and the members of MOTAG and I is really a leading piece of work and should pave the way for future instruments, so they should write it up. All right, other updates, which I'm not going to go into that much detail, that have happened over the year, which I think is significant, are the improved performance of the ASVO, which has been steadily increasing since we got Harry on board. And yeah, Harry is a superstar. And if you go and load it, see how fast it loads. Like, it might not seem important, but the stuff that's gone into the background to make it load like that is impressive. In addition, we've had improved site operations and procedures initiated by Andy McPhail. Andy has significantly advanced the way things are run on the MRO, the way that we interact with Curtin and CSIRO. And in fact, feedback from those other organisations has been that Andy has gone above and beyond what was expected in that role. So that's been really, really good. Repairs and refits have accelerated since we hired Phil. Who's laughing, but it's true. Poor Phil, during COVID, he got locked in a lab and he just had to repair things. Locked in a lab with Dave Emmerich. So yeah, above and beyond there, just for that. But anyway, they've done a really great job of repairing what was a large list of maintenance things that needed to be done. So that's been really good. And Andrew has been doing a slow and steady revision of the M&C code, and in particular has come up with some new Grafana displays for showing various different configurations of data that have been collected from the MWA and observing. Are you going to talk about that? No. So you'll have to wait for a future update from Andrew to show you how the Grafana works, because it's awesome. Right. So that brings me to the last thing that I'm going to discuss in this director's report, which is changes to the management and operations team. So there's actually going to be quite a lot of changes between now and 2021. So I'm going to step through them. They're quite complicated. For a start, the entire MWA management team will change. And the operations team will gain a member and lose a member, so remain static in number, but the scope of the work will be different. And this is due to the inclusion of the software developer position for the Oz SRC. So that's the Australian SKA Regional Centre Design Study Project, which MWA is a partner in. It's led by ICRA, in particular ICRA UWA. And as part of that work, I got a subcontract to hire a software developer to work on streamlining EOR with the view to helping design the new SKA Regional Centre, or work out the requirements for SKA Regional Centre. So I've been talking about this position for a while, but we finally hired someone into the role, which is very exciting. So this is what the MWA org chart looked like as of November. So the management team are in orange boxes and the operations team are in white boxes. I think you're all familiar with who those people are. First of all, Ricky McLernan, who is sitting here to my right, has been in the role of MWA admin officer for the last 12 months, and she has actually formally left the MWA now and works here in the Curtin Institute for Computation, which is my new institute. Yes, and Mia is giving Ricky a present. So it's a present for Ricky.
Enjoy. I picked that out mostly because I like the bottles.
So Ricky is leaving the MWA. I mean, I think some of the things that Ricky has done for the MWA in terms of making the administration work better and more efficient have been extremely valuable, and that's why I'm keeping her in the CIC. So thank you very much on behalf of the MWA.
Thank you very much.
Yeah. All right, so that's what we've got now as of December. Ricky's still here because I wanted her to help with this. So otherwise it would not be cool. And by the way, we are in the Curtin Institute for Computation. We're not in building 610 at Cairo. That's being renovated, as many people know. Okay, so Stephen Tingay has been appointed as the MWA director for 2021. I think everybody knows Stephen was previously the director last in 2015, and then it was Randall and then me. Randall will return to the role of principal engineer. So Randall was on leave and Brian was acting principal engineer while Randall was on long service leave. Tom Buller was on leave and seconded to the SK organisation from the role of MWA program manager, and so Tom will return to that role in 2021. Mia stepped up and took over that role for this year and has done an admirable job. And we could not have done the things that we've done, particularly with keeping the MWA project on schedule without the efforts of Mia, and making all these things run smoothly in the background is largely the efforts of Mia. So thank you, Mia. We are very fortunate that Mia's not actually going anywhere. She's going back to her role in the ops team. In addition to that, so you'll be seeing more of Mia. In addition to that, this is Derwent. We have hired Derwent into the, Derwent's here. Hello. Derwent currently works at ThoughtWorks in Melbourne as a software developer. And I think actually this is Derwent's last day at ThoughtWorks before they joined the MWA team in January, on January the 11th. So very exciting to have Derwent be part of the team and to work on the EOR pipeline work for the Oz SRC. Derwent, did you want to say something? Did you want to have a few words since you're there?
Totally wasn't expecting to say anything, but absolutely, completely excited about working with all of you wonderful folks. Really, this has been a dream job of mine since high school, really. I've been wanting to work on the square kilometer array for a long time. So and the MWA as well. So yeah, very excited to start next year. Looking forward to it.
You're very welcome. All right. So the last thing is that's Luke, and we've moved through to February next year. So Luke has actually indicated that he doesn't wish to continue as principal scientist, and will step down. I think at the end of January is what he's indicated to the board. So again, I'd like to thank Luke for his efforts as principal scientist over the last 6 months, but prior to that, working with Adam as the deputy principal scientist. And I think one of the last things that Luke's going to do, as he told you, is clean up all of the publications on the MWA wiki and make them all consistent. So be kind to Luke and help him with that, please. All right, so the board, or Stephen, I guess, will initiate a process to fill the role of principal scientist on Luke's departure. So that's what that looks like. And it struck me, looking at this management team here, so not the ops team, which has changed considerably, but the management team, if you could get Judd Bowman to come back as the principal scientist, then that's what we've got as a management team in 2012. So Back to the Future. So that'll be interesting. I don't think Judd will come back. All right. So just to summarize that, in case those set of diagrams wasn't very clear, Stephen, I will transition. I will leave the MWA, as Stu said, and thank you for my lovely presence. Stephen will take back the role of MWA director after a 5-year hiatus. Mia will go back to her substantive role in the MWA ops team, and Tom will return as MWA program manager after his previous secondment to the SKO. Randall returns to the role of principal engineer after his long service leave. Brian, of course, is still one of our correlator key people and in the Curtin engineering group. So Brian is not going anywhere. He's still around. Luke will be stepping down, and the board, as I said, or Stephen will initiate a call to replace Luke as principal scientist. Ricky is in fact leaving, and Derwent will be joining. So the 3 people with pictures on the left-hand side of that slide are leaving. And so I'm not going to thank myself, but definitely thank Ricky and Luke for all that they've done. Mia and Brian are not leaving, but are changing roles. And again, I thank them both for the contributions that they've made to the management team, and also to Luke for the contribution that he made over 2020. It's been really good to work with these people. And then welcome again to Derwent. So I think that's all I kind of want to say here, except that the success of any leader is only due to the quality of the team that they have to work with. And I have been exceptionally fortunate to work with a team of people who are absolutely outstanding at what they do. They are able to deal with a whole range of challenges that are completely unexpected and random, and roll with the punches. And I think that's one of the hallmarks of the MWA project. And so I sincerely thank them all for the efforts that they've put in, not just this year, but in the 3 years of my tenure as director. They have made my life far easier than it could have been. And so, seriously, guys, you rock. Something fierce. So, all right. So in summary, I think 2020 was a really difficult year for all sorts of people all over the world. So the MWA came out of it fairly well. And again, it's due to the quality of the people working on the project. So we went into a remote operations mode during COVID, and the guys did that really, really quickly. We did a risk assessment of how to do that in a week and had it done. Poor old Phil and Harry came on board a week before we all got sent home for COVID, and they've managed to survive and then reintegrate into a physically present team. We went through some difficulties with respect to, you know, repairs and getting funding for the correlator, and there was the nerve-wracking process of working on a correlator, not knowing if we had the money or not, whether or not it was actually going to happen. It all turned out on schedule, and so it's been a really difficult year, but one that's turned out, I think, really well for the project. So, yep, the MWA team continue to be outstanding and have my unreserved thanks. I think, in particular, the ASVO improvements, the MWAX work, and the data lifecycle work and site improvements were all highlights. And this puts the MWA on excellent footing to commence phase 3 mid next year. So I wish you all the best as outgoing director. Thank you.
Thank you, Melanie. Some time for questions for Melanie.
A quick comment.
Yeah.
Andrew definitely deserves a mention for the work on the implementation of the data lifecycle stuff.
Yep.
It's definitely not just me and Greg. He's had a huge role in that as well.
All right, good.
Yeah.
I knew you would. Sorry, I didn't mean to forget you. That was part of my MWA in the background. Making it go.
Any other questions or comments?
Can I ask one? Can you
Yes,
hear me, Melanie?
absolutely.
Melanie, so you mentioned this proposal called going out for 2021A. You mentioned that wax commissioning is going to be one of the main focus, but are there going to be like also support for continuation of the current projects, you know, in the sense, is there any planning for like what sort of configurations that might be available for what duration, what timeline? Is there anything that
Probably not, Ramesh. So you were one of the people that I was going to have a chat to about your Smart Pulsar survey and where that was at before I put the call for proposals out. So I think maybe you and I should take that offline and see what might be able to be done. But at this stage, the answer is no in the planning officially. I mean, you can try and use the new correlator if you want survey work. That would be possible. Oh, I can.
Okay, sorry.
Now I can see that.
Okay, happy to chat to you.
Oh, now we're gone.
Other questions?
I will chat to you offline on that, Melanie.
Yeah,
Thank
okay,
you.
cool.
Yeah.
No worries.
All right. Well, let's add our thanks to the management team for keeping things on track in, as Melanie said, a difficult year. Okay, so Melanie, I'm going to pass back to you as the chair, unless you're about to wander away.
No, I'm just changing seats so that Mia can.
We're just doing musical chairs.
We're just doing musical chairs. So yes, no, I'm happy to take back the role chair. That's fine.
All right. Bye-bye all.
I believe it's Brian's turn to give a talk.
Isn't it? Excellent.
Indeed. Okay, I'm just going to risk sharing a screen here. Okay, can you guys see that?
Yep.
Excellent. Okay, so I think everybody knows me, but for those who don't, I'm Brian Cross, and I'm going to deliver today's engineering development update. So the main big news for us is, as Melanie has said, that we've had our funding for MWAX, and that's very exciting. That's only been formally given to us in the last few days, but we've had lots of winks and nods that it's on its way unofficially, and well, for a few months now, and that's led to a real flurry of activity and work amongst the team. Some of that's been procedural, managerial type stuff that Melanie and Mia have had to look at, and I think Mia, who's coming up next, is going to mention something about the critical design review that we've just been through. But of course, the other work is the technical work, getting ready to press that big button on the telescope. Now, we submitted what I think was a pretty integrated plan. It's 21 months ago now for funding. The architecture remains unchanged. I think that shouldn't surprise anybody. It had a pretty mature architecture at the time, but there was then lots of gluing modules together that needed to be done. And I wouldn't say we are 100% complete. We are not, but we're in that high 90s stage where rather than having some independent modules that where can you send me a file and I'll process it, we have something far more integrated where you can now type an observation into the monitor and control system and it flows its way down to the correlator. We've also, in those last few months, added some support for, well, all of the existing correlator modes, which was I think one of the issues that I flagged in the July update, that not for the initial correlator rollout, but when we eventually moved to oversampling, funding bodies willing, that at that stage we weren't able to provide 10 kilohertz, 20 kilohertz, 40 kilohertz and 0.5 seconds, but we can now retire that risk. Those changes have been made, and in all our new MWACS correlator modes, we support a strict superset of the existing modes. So hopefully that will make life a little easier for the science teams in processing the data if you don't want to change and don't need to change. So we've also been doing, particularly Ian Morrison, Greg Sleep and myself, a whole bunch of hardware qualification testing, because although we did have a qualified and integrated set of hardware that we proposed back at the beginning of last year, the wheels of funding bodies apparently move slower than the development in the IT marketplace. And so some of those components that we selected are literally no longer available. And in some cases, there's just been incremental and evolutionary changes, and it is silly to hold ourselves back to what was available when we've got a whole Moore's Law increment since then that we can make use of. So we did have some tested hardware, but we have been testing to come up with a brand new set. As an example, the GPU, that was our preferred GPU at the time, was an RTX 2080 Ti, no longer available, but the RTX, it says RXT, the gamers amongst you are probably cringing, 3090 is available, and of course that should be and would be expected to be better in all regards. But for a project like this, we can't take the risk of committing ourselves to buying a couple of dozen of those without doing testing. So we've been forced to do a bunch of GPU qualification. And that sounds much more like fun than it actually is. It doesn't sadly involve firing up a single game on any of those GPUs. It is really all about running different correlator modes and checking temperatures of the card under certain circumstances and making sure that they physically fit in the rack units that we want to use and that the airflow is acceptable and all those sorts of issues, making sure that the software can run in the upgraded hardware. Anyway, that all went very well, and we can add the RTX 3090 to the pool of GPU cards that we plan on using, and when we get some quotes back, I think we have every expectation that that's what we'll go with. PCI buses have moved on. You would think that would be a very boring incremental change to move from PCIe 3 to PCIe 4, but we have to check it, and it turns out it's a very boring change, and it all went very smoothly. In the last couple of years, AMD, the chip supplier for CPUs, has made a lot of improvements, mostly in the form of multi-core CPUs. And I think anybody who's purchased computers in the last year or so would know that that price performance ratio between Intel and AMD has shifted markedly in favor of AMD. But although x86 chips are x86 chips, again, we've had to get a couple of suppliers to provide us with some AMD CPUs so that we can just verify that they've worked okay. And I'm not entirely sure what happens if I mention two potential vendors in the same sentence, but I'm going to risk that, and I'm going to say thanks to HP and Dell in particular for providing loan hardware and technical expertise when we had questions about optimum configurations for things and stuff like that. And the last one I was going to mention was a risk from the middle of the year, was that as we moved into a potential future oversampling version, we were not able to maintain the disk write speeds that we needed with the hardware as was proposed in the original funding proposal. One of the potential solutions for that was to move to solid state disks. And I don't know if Steve Croft is on the line, but shout out to Steve for actually in California getting a card that we sent him that we could only get shipped in the US, and then on shipping it to us so that we actually had access to it in a timely manner, one of the latest PCIe 4 SSD cards, so that we could test it. The interesting thing there, though, is when we tested it for mounting and field replacement purposes, it actually was not satisfactory. And I think it's one of those human nature things that when you test something and it fails, you sort of feel like you've wasted your time testing. But the reality, of course, is the exact opposite. Testing it and discovering that it was not suitable for us was perhaps the most important of the tests that we performed. But the good news is that recent updates in RAID performances and spinning disk performances and things means that we can still take that risk that we had from July and retire it as far as the disk performance speed is concerned, even with a much more traditional spinning disk in a RAID 5 architecture. So that's what we're planning. Okay, and that leads me through to the new receivers that we've been working on, because one of the, not the only, but one of the main reasons for going for the new correlator is that it would give us the provision for being able to cross-correlate a much larger number of tiles. That doesn't help us if we don't have receivers and digitizers on those tiles to do it. There's been a lot of progress by the team at the Shanghai Astronomical Observatory. That's not to say there hasn't been work at Curtin. People like Randall, certainly initially, and Jake and Dave Emmerich, and some by myself have assisted them, mostly in terms of explaining what we need in the way of compatibility modes and explaining what we're looking for in the way of output and polyphase filter bank designs and things like that. So what we're initially working there, it shouldn't surprise any of you, it's been announced several times, is to put in a complete 256 tile architecture with a heterogeneous array where half of them use the existing RRI receivers and half of them use these new receivers, but running in this compatibility mode. And I'm going to point out there that compatibility mode, unfortunately, does mean compatibility mode for such things as the current band shape on the course channels. So sadly, at that point in the roadmap, at that stop, as it were, we aren't in a position to be able to correct what I think is probably one of the main annoyances with the current system as far as the engineering team is concerned. I'll show you some of the slides. I'm not going to talk through these in any particular mode. These slides actually come from a discussion from the meeting this week with the Shao guys, and I'm only really pointing them out here to show that it isn't just a matter of digitizers and polyphase filter banks. There's all sorts of things like how the clock distribution system works for the reference clocks and how you get the network connectivity for the monitor and control that allows you to select the ports as opposed to the main data ports, and analog signal conditioning, which needs to be done at the front end. So these are slides that we were just talking through, and you can see block diagrams and indeed some engineering diagrams of how it's likely to be laid out and how JTAG and power supplies and things like that are connected up. Even down to some performance plots for the clock distribution system, looking at what sort of effect it has on phase jitter and things like that. So that's very much the meat of that sort of work, and that's progressing quite well. So what's the next step after that? Well, funding willing, we move to a 256T tile. It's in completely in native mode. And it's that point where we bring in those much talked about now oversampling, and it raises the possibility of increasing the instantaneous bandwidth by increasing the number of course channels that we have. And although I have a very a soft spot in my heart for the existing RRI receivers, I put blood, sweat, and tears into those guys, and I know some of the other members of the team have as well. I think it's fair to say that we're all looking forward to the day when those RRI receivers are shipped upstate and they can live on a farm and frolic and play in the run around in the sun and enjoy their retirement, where they will be able to play with the existing correlator who has also served us well. All of that about the phase 3 receivers is technical information about the receivers themselves, but they raise a lot of logistical issues, how we would get them out to the site, where we would put them, how do the cables run, there's tracks there that they need to cross, how would we remediate the site when we eventually need to remove it. They're things that we need to consider before we put the stuff out there. I'm going to say that I have found for that last dot point in this speech an excellent solution, and my solution to that has been to handball that entire problem to Andy McPhail, who has just taken it over. Now, I know Andy's talking later on today, or I think he's talking later on today, but I doubt he's going to get into the details of that. So I'll give you the spoiler alert now and say that at present, investigation work's done seems to indicate that we would be looking for something akin to a central core with something like a shipping container for those new receivers, and try and run RFOF, radio frequency on fiber, for the longer base tiles into that central area. Okay, final comments. I think Mia is going to handle scheduling and programmatic issues. So when we get to questions, I'm going to handball those in my normal handballing fashion through to Mia. And questions about data format, I know Greg is going to talk about what's going to happen next year as we move towards the changes that will need to be integrated into the pipelines for the science teams. And the last thing I wanted to say, as you've heard, is that I'm stepping down as the MWA project engineer, which I've been in an acting role while Randall has taken some well-deserved long service leave. I'd like to thank the board for the opportunity to do that. I've received some quite positive feedback as recently as a few minutes ago from Melanie, which is nice. But at the same time, I did get a note from Tom Buller where he described it, and I've got a quote here. He just said that my reign as the tyrannical project engineer is at an end. So I think it's fair to say that the reviews of me in that role are a little mixed, but I can live with that. And that's all I had. So I was going to throw to questions at this stage.
Do we have any questions? Sorry, we're just retethering to more stable internet here, so don't mind us.
Okay, well, since I'm
no, it's
still on, if you're doing that, I'll just try. I've just received a side channel communication from Greg, who tells me that that he won't be going into any discussing the data format change. I didn't actually think he was going to talk about it in a practical roots and nuts and bolts thing, only in sense of that engagement policy that will need to take place next year for those science groups to become familiar with the new format. And I think we've reminded everybody before, but we remind everybody again that it's more about your science pipelines, but that you cannot necessarily assume that you don't have limitations and assumptions about the number of tiles and what are valid observing modes.
Brian, can you quickly check the Zoom chat? There's a few questions there.
Quickly check the Zoom chat.
Well, there's a question that says, can somebody explain from Clancy native modes? I might have missed Brian's description.
But I think Andrew's answered that in the chat now.
Okay. Oh, yeah.
Okay.
There you go.
Yeah.
I don't think there are any other questions in the chat.
Well, I do have my hand up anyway, so I'll just continue on now. And I didn't actually want to ask a question. I just wanted to say that I'm super excited about all these hardware developments and improvements with the MWA. And this is both with an FRB and a cosmic ray hat on. And I think it's been great working with the engineering and ops teams. And yeah, I'm really looking forward to this being rolled out. So huge thanks to everyone involved with all this.
No worries. Ramesh, you have a question?
Yeah, just a quick one. So is the initial testing all going to be done on the similar bandwidth as at the moment, or is going to be done on a bit more bandwidth?
I'm just checking whether I still have my microphone working. Can you guys still hear me?
Yep.
We can.
Yes. That would be entirely up to the science teams as to what they want to try, but my expectation would be that we will begin with the, I've got to stop sharing my screen. Oh, sorry. Let me just kill that. Sorry, I hope you got that back. That we would stay with the existing modes. There's no point in making changes we don't unnecessarily need to make to the output format. So I would say the existing 10 kilohertz half seconds and those sorts of things.
Yeah, no, I think that would be, in my personal opinion, would be useful, because one of the important useful verification for any particular mode would be to cross-checking and comparing with some of our existing data. So I just wanted to clarify that will be there. Thanks for that. Yeah.
Sure. I might say that I would like people to look at the new high time resolution voltage capture, just because I put a lot of love into it, and I'd really like to see that get used in the near term.
Yeah, indeed. Yeah. Thanks.
All right. Any other questions?
We can't see hands up very well, so just shout out.
Yeah, we can't see that at all, in fact.
I've got a quick one. So you're probably all familiar with cosmic rays. Has there been consideration of whether some server grade hardware requirements like error correcting checksum memory and those kind of things were necessary? Like it just from what I saw there, it seems like going to be using lots of consumer grade hardware. I'm not sure whether it has ECC or those kind of things. Has that been considered before?
Yeah, absolutely. And one of the more recent GPUs that we've been doing that qualification testing on is the data center RTX 6000 card. It's a passively cooled card made for server grades, but it simply comes down to a funding question. When we look at those cards, they're lovely, but they're just a little bit out of our price range. And with some exceptions, one of the nice things about astronomy is that the sky is the archive. And if you lose something with a server failure or a digitizer failure, in most cases, you can just reobserve.
Any other questions? Oh, Paul, the new HDR mode is super nice. It's a comment rather than a question.
Thank you.
It's not a Zoom meeting unless someone's cat walks across the screen. It's Clancy.
Yep. All right. Well, I think that's it for questions. So thank you, Brian. And we will move on to Mia.
I know you've all been waiting for this. Hi, everyone. I'm Mia Walker. You might remember me from such conference talks as My Favourite People Are Cats and How to Make People Remember Your Talk for All the Wrong Reasons. Today, I'm going to be talking about the next phase of our telescope again, as if it were a Pokemon that we've been leveling up and is about to undergo its final stage of evolution. Now, after our last project meeting, we had a lot of really positive feedback about the ops team talks. And for a while, we all felt pretty chuffed about ourselves. But then I realised that the reason that you guys liked hearing Annie kicking around in echidna was because most of our collaboration members have never even had a chance to go to site with the telescope that they use, which is a real shame, because it means you're missing out on all this amazing stuff like Bunga is doing yoga and our RFI elimination and response vehicle to pinpoint the visitors who dare to come to site with the Bluetooth enabled on their laptops. So with that revelation, we dedicated this half day of project meeting talks to the ops team and what it's like to get down in the dirt of the Murchison, like our fabulous acting principal engineer, Brian, here. I've included his email so that when you get a chance, you can wish this guy a happy birthday for Wednesday or just to laugh at him. Is that changed? On the screen? Oh, okay, right. Well, I'd like to keep this energy going, but I think the board would be relieved to know that I do have some more serious slides. This may or may not be one of them. And you might be surprised when I tell you that we only have 6 months left of phase 2, or you might not be surprised because Melanie informed you that we only have 6 months left of phase 2. And what does that mean? It means this lovely signal chain that you've finally gotten used to writing about in the introductions of your papers is going to be overhauled again. And there's a bunch of reasons for that, of course, but the most important one is the fact that this equipment is super old. Our correlator is so far past its retirement age that keeping it going feels like an act of cruelty at this point. And we're a little scared to turn our receivers off because the CPR routine to get them back online is getting more drawn out every single time. So we knew for ages that we need to be putting in new equipment, but we also knew that given the chance, we'd do things a little bit differently, not just for our sakes, because, you know, the people that maintain the instrument, but for yours, because I don't think I've heard any astronomer actually say that they like our channel edges. So we took this as an opportunity to design for improvement, to deliver some much nicer data products for you guys. And some of the changes that we plan for phase 3 aren't set in stone yet. As people have said, that's going to take some time and some funding contributions to put in place, things like the new receivers. But the first thing we are going to change as soon as we can is the correlator. And boy, are we excited about it. And you can forgive me for talking about this because getting the MWAX project executed has taken a lot of effort and a lot of documentation that's only going to be read by a very few number of people. But it was all worth it because we received funding approval from AAL just last week. And you might have seen in the media release yesterday, Gamers pave way for $1 million grant for telescope brain upgrade. Now, I assume when they say gamers, they mean us in the ops team and the impressive amount of hours that we collectively spent playing Zelda. We even have a Slack channel for it. Now, the 2020B observing semester that we are in now, that ends officially in January. So the MWA is going to lie mostly dormant from February until we remove the legacy correlator that you're all used to and we reconfigure the array. And we expect to do that in about March or April. And after we plumb up MWAX, the new correlator, and we do our tests, we'll have those shared risk observations that Melanie talked about during the science commissioning part of MWAX. And that'll be around the middle of next year. And just in time for phase 3 to begin officially. Now, this is my version of Ellen's backstage 2014 Oscars photo taken on Tuesday this week at our critical design review of MWAX, which was a rather formal milestone for an MWA project to have, given how small we are in budget and FTE compared to some other astronomy projects. We'd like to thank the panel members again for their time and for writing up their reports so close to the end of year holidays. I, for one, don't plan on doing any more thinking after today's meeting, or indeed after this talk. Melanie's already gone through this, so
but talk about the Grafana. That's awesome.
Andrew was right here, but apart from the MWAX developments and the observations during Space Fest this month that were made with it, we've also been collaborating on some new receivers with Shao, which Brian mentioned. And Greg's going to tell you about the archive and how we're implementing the data lifecycle policy that was announced at the last meeting. Our ASVO web developer, Harry, has been making a lot of long-awaited updates. He'll tell you a bit more about that. And Andrew has been doing lots of work on ways to visualize MWA statistics, such as with this plot of the observing schedule that was made in Grafana, showing all the different projects that we had online at the time. We've still been able to go to site despite COVID restrictions. In fact, we're quite lucky to be in Western Australia. And we're used to operating our telescope remotely because it means that we're able to continue the work that we planned without many delays. We've been upgrading our beamformers as part of our obsolescence management program, which our technician Phil is going to tell you about, probably without using the word obsolescence. Having site access. Having access to site also meant that we could install some cable trays to protect the power and fibre around the site and ensure all the current infrastructure that we have is suitable for the early stages of phase 3. And we also have a talk from Andy about a day in the life of someone on site, that someone being him. And in a twist of irony, it's been pre-recorded because he's busy on site. So hopefully that works. This was the timeline slide that I used in July this year, and surprisingly, I don't think it really needs to change too much. I've added a couple of dot points about the new correlator. We weren't sure about the schedule until we got the funding last week, but if we can secure some hardware early next year, then we'd be on track to have it commissioned and ready for the 2021B observing semester. We expect to receive the first prototype receiver from Shao by mid next year, and that's going to help us decide where we're going to put them once we have enough of them to digitise all our tiles in the field, and maybe enough eventually to replace our old receivers entirely. Phase 3 begins officially with a new ops contract in July 2021, and we expect it to run for 5 years, with the last 3.5 or so being in a full 256T configuration should everything go to plan. And after phase 3 is complete, the ASVO node of the MWA is still going to be supported for 18 months to deliver access to your proprietary data. Melanie and Luke have already given a recap of the year from the management and the science sides of things, so let me tell you about operations. It's not all fun and games in the ops room. In fact, that room has been dormant for some time now because of a building refurbishment, and before then because of COVID. So we're all spread apart, either working from home or in different offices around campus, and it's really weird to be with these people right now in this room. That didn't stop us from welcoming 2 new ops members into the team this year. And, you know, sitting here, I think this is the most contact we've had since we interviewed them. I did want to touch on some of the lessons we've learned in the MWA this year because, you know, reflection is good for growth and all of that. First off, the saying that prevention is better than a cure. Absolutely spot on. Having Phil on our team as a technician this year, we've been able to get through our considerable backlog of repairs for all the broken bits and pieces of the MWA that we cannot replace or cure. And it's allowed us to work on things like beamformers, which aren't quite broken yet, but very nearly would be. So he's probably a very big part of the reason that the MWA continued to work smoothly this year, even when we couldn't get to site for months at a time. Second one is measure twice, cut once for engineering development. Talk about your design with people. Bring in as many external perspectives as you can, which is going to help retire a lot of risks and just obvious things that you've missed because you're human. Documentation, everyone hates it. I don't, I'm weird. I find it very useful, but this year helped me understand why other people don't like it. It's because you should only be writing down stuff that you actually need to remember or stuff that other people might need to know. Don't just write things for the sake of it. Figure out why you're making a document, who's going to read it, and then actually tailor it according to that. And if you're asking someone else to document something, tell them why, what it's going to be used for, who's going to see it. Same thing goes for meetings. If you can't articulate why you need to have a meeting or a document, the next step might be to actually reevaluate whether or not you need to do it. Now, I think I found with the travel restrictions and working from home, we've all gone through this process of reevaluating our schedules, figuring out what's really necessary to attend, how we can still be a part of it. So virtual conferencing has come a long way, and I think that's excellent, especially because, as per my last dot point, email communication doesn't convey tone very well. It's very one-dimensional, and that's important to keep in mind. It's not a good idea to write things in emails that you wouldn't say to that person. And on the other side of the coin, it's probably best to assume that people always mean well. But if this year has taught us anything about MWA operations, I think it's pretty robust. We've had, as Melanie said, hardware failures, power outages, travel restrictions, isolation, puns, you name it. Despite all that, we've managed to collect hundreds, if not thousands of hours of observations and petabytes of data. We couldn't do it without the support of you guys, our collaborators, putting in bug fix requests and asking for more info on something or volunteering to be part of our engineering development processes. I mean, I know it sounds weird, but that's what keeps us going. We're here to serve you guys and to provide you with the best data that we can give so that you can do the best science possible. And I want to thank everyone, the ops team here and Melanie in particular, who have helped me this year as MWA's program manager. I've had so many really good learning experiences and I'm very grateful to be given the opportunity. And I look forward to figuring out how I can serve you in the future. And that's just about it from me. And usually at the end of a talk, I show the MWA partner institution slide with all the logos. But that seemed kind of impersonal, especially in a year that's kept us more apart from each other than usual. One thing I find reminds me of how connected I am to everyone else on the planet is the moon, because that's something that all sighted people in history have seen at one point in their lives. So I'm going to end here on Ben McKinley's gorgeous picture of the moon using MWA data to show the rest of the universe reflected in it. Thank you very much. Any questions? I'll clap myself then.
Yeah, always doing everything. All right, indeed. As Mia has already said, we can't see hands up. So either put your question in the chat or shout out. Okay, Ben has noticed it's the moon. That's good.
Just comment award.
Yeah.
Moon.
What's the cat's name? Can I just say, anyone who thinks that unnecessary meetings should be cut is a winner. It's one of my personal philosophies. As you know, pointless documentation I'm also not a fan of, so all good. Yes.
I think we're quite early for our break.
We are very early for our break. Actually, I was going to suggest, since we're running early, that we let Greg jump in and do his talk if he's ready.
Yep.
Because apparently a TV crew is coming to interview me to talk about the correlator and the funding. So that'll be exciting.
Okay.
So somebody else will have to, when they get here, we'll have to rejig. But yeah, it's all happening here at the MWA today. We're just rolling with the punches as normal. Okay, so no one else has anything for Mia? No? Okay, so again, I'll just say thank you to Mia for her contributions to the MWA management team and making sure that we had things presented in considerably better and less ad hoc ways than we had in the past. Despite the fact she can't make me use an MWA template, she did make everybody else do it. All right.
Cool.
Greg.
Ready to go.
All right.
Well, good morning, everyone, or evening, or wherever you are. Yeah, I'm the MWA data manager. And today, my main aim is to give you all, as soon as I can figure out how to proceed in my slides, there we go, a bit of a state of the archive update, an update on the newly published data retention policy, an update as well on how we went with our Ruscio evaluation that I mentioned in our project meeting last time, and also just an overview of where we're at with realigning the archiving data flow for phase 3. So this is the state of the archive at the moment. So we're at 36 petabytes out of our allocation of 40. Melanie mentioned in her address about the fact that Pawsey had some issues. Earlier, or in the last sort of 4 to 6 Pawsey had an issue with our all of our allocation. Pawsey option that they've given us seems to be a virtual option. They've recently got new tapes in that's now free to use our full 40 petabytes if we need it. So as you can see in this plot, I guess the main thing to see is just where phase 2 started, which was in the end of 2017, and you can see the data rate really ramps up here. This is actually a plot that shows the net growth of the archive every month. I've previously shown a plot that was more of a naive view of how this works, and this is actually a much more accurate plot. I fixed the code last night. So as you can see, we actually had in around the May time an actual drop in the net archive usage, which is good. So I want to do a shout out again to the EOR team and also the VCS team for working with me to cull a whole heap of redundant and unneeded data. And that's really helped keep us down below our limit with Pawsey. And it's basically meant that it's given us time before having to actually action the data lifecycle policy, because I'm sure everyone would agree that if we can keep control of the data that we've got in the archive, we can make sure that the stuff that we want to keep stays in the archive for as long as possible. So this is actually what the ingest looks like if you don't include any deletes. And so this shows that we've accumulated more than 46 petabytes of data since commissioning. And so we've deleted over 10 petabytes. And most of that has happened in the last year. So once again, without the help of people providing me with things to remove, we would have sort of hit our wall a long time ago. So this is just the last 6 months, and I really love that first column there, because that shows that we actually had a net drop of the fact that we were not ingesting much because of an outage on site due to power works, I believe, or cooling works. And I happened to do a whole bunch of deletes as well that month. So as you can see, overall, we've been pretty steady at around the 35, 36 petabytes for the last 6 months, which has been really good. So if you look at just the ingest and don't count any deletes, this is what our last 6 months looks like, including a little 7th month here, which is just what we've done this month. Looking at the schedule, it looks like the next few weeks in December and then the 4 weeks in January are probably going to be quite low as well. So I think we've gone through the worst of it in October, November and September. So this is where we're at in terms of the current usage for individual projects. So I haven't grouped it by science working group, but just by individual project. And I must point out here, and Ramesh would chastise me if I don't mention it, that the VCS contribution, which is mainly the SMART survey and the VCS FRB project, which is G0024, those two added up, we need to subtract about 1.5 petabytes or so, because they've given me a whole bunch of things to remove that are redundant and unneeded, and I haven't got around to doing that yet. So I hope to do that next week. So they'll have a bit more, a bit less usage. Another interesting to note is just how big the other slice of the pie is becoming. It goes to show that we've got a huge or so with our, I believe as well, the ASCAP just over 3 petabytes. There's a whole bunch there that's probably earmarked for removal as well, which will help. So I'll be following up on that in the new year. And I must point out as well that EOR, which used to be one of the biggest contributors, is now way down in about, 8th place or something. So thank you, EOR team. And I know you're collecting new data and stuff, but yeah, that's really good. So the data retention policy got endorsed by the board and published quite recently, I think at the end of October or so. And I'll just walk through with you, I guess, the high level description of that policy and how it's solidified. And Harry, in his talk after me, will be going through and describing a bit on how it will actually work from the end user point of view, whereas I'll be talking about it from the system point of view. So the main takeaway from the data retention policy is that we're breaking the archive capacity down into 3 main sections here. So the biggest section is a general section, and that is basically what we'll be utilizing as our first in, first out type queue, I guess, for observations. So observations in this area are the ones that we will be removing in order to make space for new observations. The orange slice of the pie there, the DG quotas, and I'll explain what DG means in a minute, that is the data that's reserved and will not be removed no matter how old it is. And I'll explain that system in the next slide. And we've got a reservation of 4 petabytes in the gray area there, and that's really just a buffer zone to make sure that through the process that we go through, that we always have room to ingest new data and will never sort of be caught short. So DGs, the data groups, is defined in the data retention policy as being groups of researchers. And initially, the data groups will map pretty consistently with the existing science working groups. However, there will be a MWA group thrown in there as well, and that's to manage anything to do with the MWA as a telescope. And also other data groups can be formed as well with direction from the director and the management team for specialized purposes or where researchers are not actually members of any of the existing science working groups. So the idea is that data groups own a quota, and so they own a slice of the orange slice of the pie there. And the quotas are determined by the director with input from the science working group leads and the project scientist. Quota changes can be made during the call for observing proposals. And this also means that if we get new capacity from PAWSI, for example, if they bump us up from 40 petabytes to 50 petabytes, unfortunately, we don't have any confirmation that's going to happen anytime soon, but one day it will. Then that is where the people can propose that their quota gets increased, so their data group quota gets increased. The quotas may also be reduced as well if there's some good reason by the director or the management team. But effectively, the data group leads, of which there'll be 1 per data group, will own their quota and be able to manage what observations that they protect from any sort of removal or automatic deletion. And as I said before, Harry will talk about how that will actually work in reality. So a data group lead can actually protect any observation from anywhere in the archive for any project. And so of course that also means that in theory, multiple data groups could in theory protect the same observations, but that won't be an issue. So protected observations won't be removed when we actually go through the cycle every month of removing the oldest observations. And these protected observations, they expire after 12 months. So the idea is to provide enough time for the science groups to copy that data to somewhere else or to, I guess, to make other arrangements to ensure that that data is safe. They can also be reapplied for after that 12 months as well. So that is fully up to the data group lead to manage that. So this is how it will work on the system side. So on the first day of the month, we'll identify the oldest non-protected observations that we need in order to make that general slice of the pie more than or less than 90% full. And we'll email out a report to the collaboration showing a summary of which projects, OBS IDs, dates are affected by by the delete that would happen at the end of the month. So during that month, the data group leads will then be able to look at that list and manage their protected observations as they see fit. They may not care to do anything during that month, so that's fine. On the last day of the month, we'll actually go and remove the oldest non-protected observations until that general slice of the pie is less than 90% full. And so that will basically occur every month once we begin this process. So the initial implementation, as Melanie said, will be during Q1, Q2. Harry will talk about the UI changes and how to manage that through the ASVO. The first cycle that we do is obviously going to be, something new for all of us, and we want to make sure that everyone has enough chance to review what may be removed in these oldest observations, and have a chance to make sure that if there is anything critical, that it gets protected. So the first time we run through this, we'll actually extend the process out a bit. It won't be a month. We might make it 2 months. So that way there's plenty of time for people to review what's going to happen before anything happens. So this is a necessary change in how we run the archive, just due to the fact that we have limited capacity. Pawsey is not necessarily going to be able to provide us with unlimited storage going forward. So we need to manage the 40 petabytes we have in a responsible way. So you can see here, this is my life cycle, I guess, of how observations will work in the MWA with this policy in place. And the last 2 bubbles there on the left-hand side is really where we're adding these steps to the existing process. So the idea would be to keep in mind the life cycle of your observations as you are putting your proposal in and working out exactly what you're going to be observing and how long you want to keep the data. So onto the next one, which is an update of the Pawsey-led Ruscio evaluation. So Harry and I were part of that, and we assisted Pawsey in looking at Ruscio. So MWA was one of the use cases that Pawsey was interested in looking at. So they are implementing a new long-term storage and a few other new systems in the next year as part of their $70 million refresh. So Garawala was one of the first cabs off the rank with that $70 million refresh, and that's successfully been implemented. So with the Ruscio evaluation, just to remind everyone, this is some software that CERN developed for the Atlas experiment. And currently they have 500 or so petabytes under management in Ruscio. What we found though in our evaluation, and it's definitely what Pawsey remarked on as well, was that it was very Atlas focused. So the non-Atlas use cases were not very well supported. There was a lot of bugs and issues in progress for people that weren't doing things the same way that Atlas were. There's a very, very large technology stack required to run the system. And even with Pawsey's much larger system admin team than MWA has, even they were quite put off by the sysadmin load that would be needed to run Ruscio in Pawsey. So Pawsey effectively, I guess, closed the book on Ruscio and decided that they would not pursue any further evaluation with it. They've got a report that they've written up that we should hopefully get off them soon. However, we did actually get a few good things from this experience. So we learnt about a tool called XRootD, which is what the Atlas experiment uses for a lot of its data transfers over long distance WAN connections. So I've been evaluating XRootD as a way to move data from the MRO down to Pawsey for the phase 3 data flow. And it's actually been very successful and very easy to use and superior to the previous ways I've been doing data transfers. So we actually feel like we've got quite a bit of use out of that just for this one thing. And that even though Pawsey are tight-lipped about what their new long-term storage is capabilities, because they're in a procurement process. But they were telling me that many of the things that we were looking for in Ruscio are part of the requirements for their new long-term storage system. So we'll be working with them in the new year as they go to market and get that implemented. So this is a slide we've seen a lot of the time, phase 3 data flow. I just wanted to, I guess, point out a few things where we've actually progressed here. So in that first bubble at the MRO, that's where we will have the correlator and online archive. And so we've been, as Brian said, we've been doing a lot of testing and benchmarking with MWAX servers and equipment. Over on the right-hand side there in the Curtin University bubble, we've got our 10 data cache servers. So these are already installed, implemented, and we've basically got them all good to go, ready for the data flow. We used these for the recent SpaceFest observations and successfully stored the observations there before sending them on to Pawsey. And down at the bottom of that 100 gigabit link, where we've got the ingest servers, Pawsey have delivered them to us, and we're now setting up our software on those servers. And so the idea is that early in 2021, once the 2020 B semester finishes, we'll be realigning our data flow so that the data will go via the 100 gig link from the MRO to the data cache in Curtin, and then across another 100 gig link over to the Pawsey Center through these new ingest nodes. So that's a really big step towards the phase 3 implementation, and it basically takes care of everything outside of the MRO bubble there. And I've also been working with Pawsey with their new long-term storage architecture as well, in making sure that we can ingest data in a much higher rate than we have been so far, because the MWAX initially will only be at 128T, but eventually as phase 3 gets implemented, the data rates will go up quite a lot when we get to 256T. So we're just making sure that we're ready for that. So yeah, so this is really what I was just talking about there. We'll be using X3D to push data. We've got our cache servers set up, and yeah, we hope to help Pawsey with their testing of their new long-term storage system. And I think that's it for me.
Very good. I'm sure there will be questions. So again, if you've got your hand up, we can't see it. So either put something in the chat or shout out. Maybe someone could tell us if they could actually hear us. Thank you, Clancy. Ramesh.
Yeah, so do I go first or Clancy?
Yes, please go first.
Okay, so I'm just trying to get some clarification on that the slice of the orange that you mentioned, Greg, and you said that there's going to be some periodic review. Is that for the sub slices within that slice, or is that what is the level of flexibility of that so-called DG quota? Because that is going to impact some of the longer term planning of some of the projects. And so I'm just imagining that this will apply to everyone, but I understand the other constraints as well. So yeah, I was just asking what's the current plan or process that is in the picture.
Yeah, so I think what you're asking really is how are the data group quotas assigned? Is that what you're asking?
Yeah, that's right. So how that orange slice is going to be managed, on what is the process for, like it's a review or reallocation or whatever?
Through the director. So Ramesh, the policy basically gives us the responsibility of the director. So initial quotas will be set based on historical usage and what seems to be fair. If they need to be revisited, that will have to go through the director as a review process. And the split is based on use for other instruments. So what's typically used for other instruments.
So would that be like an annual process, or how periodic is that such a review?
Well, you could do it as an annual process. I mean, I'm going to step down as director, so I can't really speak to the cadence on which this review would be done. I would think that we would want to run the system for at least a year before coming back and seeing whether or not this was problematic. You know, you've got MOTUG, so you've got the MWA Operation and Technical Users Group, and that's the forum through which to pass information to the director around this sort of thing. So I would expect if science groups and data groups are having problems, you would contact MOTUG and they would alert the director, and then something could happen on whatever was the appropriate timescale.
Yeah, thanks, Melanie. Yeah.
No worries.
Clancy, you've got a question/comment.
Yeah, so my comment was good to see that XRootD is in there. We've been using it for KM3Net for a bunch of years and in the computer center in Lyon. So that's nice to hear. And also it doesn't surprise me that the software stack coming from something like Atlas is ridiculous. I was going to ask, how far back has this experience with the software stack being sort of prohibitive and being passed back up to CERN? Because in theory, when these guys apply for funding, they'll be saying things like, the software we develop will be of broader usage to the community. And in theory, they should care about whether or not they're developing something with too many dependencies to make it worthwhile. So has the feedback, how far back is the feedback going?
So I believe that I don't think Pawsey has provided the feedback back to CERN yet, although I suspect that's in the works, and I'd like to contribute to that as well. But yeah, you're right. It is tricky, and part of the difficulty with Ruscio is simply the fact that it uses so many different technologies and bolts them together. So you really need to be an expert in many things in order to administer this. And Pawsey were estimating that they would need 1 or 2 FTEs just to manage the software stack for a Pawsey-sized implementation, which would include an MWA use case. So it certainly is out of our league as MWA. And for what we would get out of it, it probably wouldn't be worth the investment, even if we had, an extra $500,000 for salaries. I think it's better for us to piggyback on what Pawsey is doing when it comes to data management and being able to send data out to different parts of the world. I mean, the MWA ASVO can already do that in bulk. It could probably be made easier than it currently is, but we certainly have a few science teams out there that are downloading stuff in bulk, and we don't need any special extra stuff like Ruscio or anything from Pawsey to make that work for us.
Okay, cool.
Other questions? No? All right. So I think we'll move to the break now, not least of which because the TV crew is turning up here in 5 minutes. So we are scheduled for a 20-minute break, which would put us to coming back at 5:02, the hour. So we'll aim for that.
I might test Andy's recording, so if you hear noises, just ignore them until we come back from break.
All right. Thanks. Thank you.
There you go.
Welcome back, everyone.
Okay, Melanie's still on here, so we're going to go to Harry's talk on the new MWA ASVO.
Hello, everybody. My name is Harry Barlow, and I'm the lead developer of the MWA ASVO. And today I'm going to be talking a little bit about the maintenance work that I've been doing on it since I started back in March of this year. So I thought that I'd start off just by talking about what ASVO is in a little bit more of a general sense, because it's not something that is specific to the MWA in any sense. I'm aware that a lot of the information that's going to be in this talk is not is stuff that a lot of you are going to be aware of. But I thought that it was important to reiterate some of this stuff for the benefit of members of the collaboration and just to sort of hammer home some of these original goals as well. So there's actually 5 different nodes of the ASVO collection of projects, of which the MWA is one, with the others being TAO, SkyMapper, AAO Data Central, and CASDA. So it's an Australian initiative that aims to facilitate collaboration between different nodes that have a similar set of goals, values, and challenges. So now just reading from the AllSky Virtual Observatory website, the AllSky Virtual Observatory enables researchers to access data across a federated network of datasets from astronomical facilities around Australia. So just a very brief introduction to the MWA ASVO. So as a lot of you know, it's a web-based portal that was launched in late 2017 that was built to serve out raw visibility data to astronomers. It was built to allow researchers to easily find observations according to a large number of criteria, which I will talk more about later. The data is served out either as raw visibilities or calibrated visibilities. It supports a large number of options for pre-processing data using Coda. It supports a number of various VO standards to ensure that all data follows fair access principles. So just a quick note on fair data and how that applies to the MWA ASVO. So we try and ensure that all observations are very easily findable. So all MWA observations have a unique handle, which is known as the OPS ID, obviously. Accessible, so we provide an IVOA compliant table access protocol service to allow compatible software to easily discover observations and associated metadata. Interoperable, so the MWA ASVO allows users to download data either as CASA measurement sets or UV FITS files, which are 2 very widely used radio astronomy formats. And reusable, MWA data provided by the ASVO contains metadata, which describes a rich amount of detail about the observation and how the telescope was configured. So a quick note on how the ASVO addresses the use of fair data. We did that by the implementation of various VO standards, which are supported by the IVOA. So there is the table access protocol service, like I mentioned before, which can be easily accessed using software such as TopCap. It implements all of the standard OBSCOR schema in addition to some MWA specific metadata. VO table, so MWA ASVO users are able to download observation metadata as a VO table XML format, which is compatible with all sorts of software. We have implemented the simple cone search protocol, allowing users to quickly and easily find sources of interest in the sky. ADQL, so in addition to using our web search interface, users can also query our TAP service using ADQL. And SSO, so while this is not obviously a standard that is specific to astronomy or anything like that, it is supported by the IVOA, and we've implemented that in a number of different ways. So one, if you've logged into or registered with the ASVO before, you'll know that you can register with your institution account or something like ORCID. And there is also an OAuth integration, which was launched this year with AAO Data Central. So what's new? So probably the biggest change that I have made since I started with the MWA Ops team back in March has been a redevelopment of the whole front end. So while a lot of the sort of look and feel is very similar to how it was previously, it has been all re-engineered from the ground up, with the biggest change happening on the observation search page. So whereas before it was fairly limited in terms of how you could drill down for the observations that you were looking for, you can now search for observations using over 30 different parameters here in the sidebar, with the results being displayed in the table just here. So some other features that I've been working on, like I mentioned before, is two-way SSO with AAO Data Central. So you can now register and log into the MWA ASVO using your Data Central account. And very soon the reverse is going to be coming as well. So some of the smaller features that I've been working on is responsive development, which is essentially the process of making the web client perform better on mobile and tablet devices. So if you're ever wanting to do a bit of astronomy on the go, you can do that now. And improved usability. So you're now able to get some instant feedback as soon as you create a job, whereas before, if there was an issue, you might have to wait a couple of days for it to be scheduled and processed before you were alerted to the fact that there was an issue. You can now also edit your profile and generate a new API key. You can also set a custom expiry date on your jobs. So whereas at the moment, so whereas previously there was a 7-day expiry, so when your job was completed, you had 7 days to go and download it. You can now set that to something shorter if you want. And that was a result of one of our users who added about 26,000 jobs onto our download queue, which caused all sorts of issues. So we had to implement some sort of restriction on how many jobs people could have on the queue at any given time. But if you set a lower expiry date and you're still able to download the data before it expires, then that will allow you to download more jobs per unit time. There are also more RFI flagging options for conversion jobs and the ability to set a custom phase center as well. So some of the work that's going to be coming soon is a new status page. So this has been something that has been in the works for a while and something that people have been asking for some time. So very soon you'll be able to see information about the jobs queue, such as how many jobs are queued up for both download and conversion jobs. You'll also be able to see information about a project's data usage within the archive, such as its growth over time. There's also going to be some new processing nodes over at the Porty Supercomputing Center. So while there are 2 at the moment, there's very soon going to be 6, which is great news because that means that there's going to be shorter wait times for your jobs to be processed. So the servers have all been provisioned. They're currently in testing, and the ETA is looking to be late January/early February. And a lot of the work that's going to be happening over the next few months is the implementation of the data lifecycle policy, which I'm going to be spending some time talking about now. So I'm just going to give you a quick UI demo to show you exactly how the reservation and deletion requests will be integrated into the current ASVO front end, as well as any other supporting features and pages that we're going to be working on to help facilitate this whole process that Greg mentioned just earlier. So essentially, we're going to be integrating the deletion and reservation functionality into the existing search page that I showed you just earlier. So let's say that you were logged into the ASVO as the PI of, in this instance, the Solar Observations project. Shout out to Divya if he is here. And if you are the PI of that particular project and you're searching for it, you will now see a red button above the search table, which will allow you to delete or flag the selected observations to be deleted at a later stage. So when you would click that, you would be prompted with a modal, which would ask you to provide a reason for marking these particular observations for deletion. And similarly, if you were logged into the MWA ASVO as the lead of a data group, and you have selected some number of observations, you will then be able to press this green button here, which will mark them for reservation, and they will be added to your quota. And again, you'll just be prompted to confirm that. So some other features that we're working on to assist with the management of the data lifecycle policy. So like I mentioned with the status page before, that has now been expanded so that you can also, in addition to the metrics that I mentioned earlier, see some information about how much quota you have and how much of it is currently being used up. And there's also going to be a page to view your reservation and deletion requests, and you can manage them further from there. You can cancel them and see further information about them and that kind of thing. So just over to some quick user stats. So these are accurate as of the end of Q3 2020. So we currently, as of then, we have about 450 users, of which about half of those are from the MWA collaboration itself. Roughly half of those users are active. We have completed over 200,000 download jobs, serving out over 4.5 petabytes worth of data, which is quite remarkable. And there's also been about 3,000 website logins and almost 200,000 API logins as well. I also just wanted to take the opportunity to thank anyone who who answered my call to provide some feedback recently. I am not an astronomer, I'm a web developer. So any changes that I'm making to the ASVO are purely guided by either my own experience or sort of the small amount of user feedback that we do get, as well as some consultation with the operations team. So just want to make it clear that we're always open to suggestions, improvements, and feature requests. Like Mia said before, we're pretty much here to serve you guys. Tell me how we can make the ASVO help you do better work. Feel free to drop a line at asvo_support@mwatelescope.org. Just a quick note as well, I have pretty much taken over all sort of control of this from Greg now, so definitely bug me with that stuff instead of him. And thank you.
All right. Do you want to keep sharing or shall I?
No, go ahead.
All right.
I've got a comment. So I just wanted to point out, as Harry said before, so Harry's taken over looking after all of the ASVO stuff from me. And I've got to say that I'm extremely impressed with how much Harry has come up to speed so quickly, and that basically he is doing the whole thing now, and I could get hit by a bus and the ASVO and the ASVO would keep going well. So just a shout out.
Everything else would.
Well, yeah. Because it is a really steep learning curve, and Harry's come in with an enormous amount of software engineering and web experience that simply I didn't have. So it's really great to see that the ASVO is moving along really well. It's in safe hands. Good stuff.
Very good. All right. So, questions for Harry?
Yeah, I mean, more than question, I just wanted to comment that those features are excellent, and I can see that some of the coordination that we have been trying to do to identify spring cleaning the data or wants to keep those things will become incredibly efficient with those red and green features. So thanks very much for implementing that, Harry. That's really look forward to that making this process more efficient for us and also for you guys.
Thanks, Ramesh.
Hi, Divya here. I also just wanted to add my voice to thank Harry. Thanks for including the custom phase centers for us. It's very helpful for Shy work.
Oh, yeah.
Thanks.
You're welcome.
Thanks. Yeah.
All right. Let's kicking off.
Right. All right. Well, before you disappear, though, I'm just going to say that this vindicates the thing that I've said for many, many years, that at some point astronomers can't write hacky code, and you have to actually get professionals to come and work with us. And so I think the amount of changes that you've been able to implement, improvements that you've been able to make in the ASVO and both the back end and the front end in a very short amount of time is really testament to that. And I think that if a comment that I want to make to the community is that this is the way forward, that we need to work with professional software developers such as you and Greg in that symbiotic way to be able to scale up and do the things that astronomers want to do. So,
and a benefit everything else. Like one throwaway comment from Harry changed my entire life. Have you considered Redis?
Yeah, well, that's also good. All right.
Oh, sorry. Oh, it's Andy's talk. Oh. We can do Andy's talk. Now, I did test this, so hopefully.
Andy's on site.
Andy is on site, but that's okay because he has pre-recorded his talk and sent it to me. So let's try this. Sorry for making you panic there.
That's still my hardest hack. You can't do that.
Okay, so whoops, hang on. Let me just. Okay, hopefully he starts talking soon.
Good morning, everyone. My name's Andy McPhail, and this is a brief pre-recorded presentation about site trips on the MRO. The presentation is pre-recorded. My apologies for that. I was hoping to give it in person, but unfortunately I'm on site this week and the activities have been a little bit full on, and I'm probably at the moment deep inside receiver 7, replacing an ASC that decided it didn't want to play the game last night. We need to get this receiver back up and running before the Christmas break. Apologies for that pause, a bit of a technical problem there. So the key and the driving aspect of all site trips is the 7 Ps. And I'm sure you've all heard of the 7 Ps. The politically correct 7 Ps I'll give you now is prior preparation and planning prevents pathetically poor performance. This is a guiding principle that I try and instill into all new people that come to site, whether they're coming up to install their own equipment or coming up to support our site activities. There is no Bunnings, there is no Altronics, there is no mini circuits. You have to take everything that you're going to need, and you have to take 2 of everything that you're going to need. Chances are the first one will break or fail, and you'll definitely need that second one. And if you haven't got that second piece of equipment or minor component, then at least, correction, if you do have 2 components and the first one works, well, guess what? You've then got a spares pool on site for us when we have to repair or fix your equipment in the future if something goes wrong. So I stress to everyone that if you do get the opportunity to come to us on site, whether it's installing your own equipment or supporting our site activities, we will smash you on the 7 Ps. We will ask you quite a lot of detail. Having said that, it's something that we often do fail on. We'll get to site and go, oh, I don't have it. It's just, that's how it is sometimes. So this presentation is going to cover some basically broad activities that occur on site. And they're going to cover just some broad topic areas. The reason for this presentation is we're always asked about site trips. What do we do? How do we get there? What's it like? So hopefully this will cover some of those questions. Please feel free to always ask them. But more importantly, from next year on, activity on site is going to become significant. There's going to be a significant more activity on site. We have, from an MWA perspective, the new correlator being installed. We've potentially got new receivers coming our way, and they're key items as we lead up to a 256T operation. 256T operation will require more maintenance and more site trips, because we're not just doubling the amount of tiles, but we're literally doubling and increasing the amount of equipment that we've got to maintain all year round this time. On an SKA side of the house, the validation of the antenna design and the RF signal chain will be occurring. There'll be some new and significant equipment installed on site. The tile processing machines will be moved into the remote processing facility, and we'll really be testing and validating the antenna design and RF signal back to the main building in an attempt to find all the faults and weaknesses in that design so we can improve before construction. Then on the external instrument side, we've got hopefully three external instruments that will go on site this week. Correction, not this week, next year. And they will be important instruments for those project managers. So that's why we're presenting it. Hopefully it'll fill in a few questions that you may have, and just touch base on what we actually do. So how do we get to site? Or how would you get to site if you're coming to site? The most likely way you would get to site would be via a fly drive. So you would fly to Geraldton, and then it's a 1.5 hour drive out to Pindar on a sealed road. And then it's a roughly 2 hour drive to the Bellardi accommodation facility, which is approximately 40 minutes short of the actual observatory on the MWA site. And the Bellardi accommodation facility is where we leave from and return to on a daily basis. That whole trip it's got about 3 to 4 hours of driving with a 1 hour flight, but it generally takes about 8 hours. And the reason being is that you have to get to Perth Domestic Airport quite early. Perth Domestic Airport has literally between, the flight to Geraldton leaves at 7 o'clock in the morning. Between 6 in the morning and about 8:30 in the morning, there's anywhere between 1,000 to 2,000 people, all fly in, fly out mine workers trying to get on their planes. So it's a fairly hectic operation, and that does place a lot of stress on the choke points in the airport, particularly security screening. You'll often find you'll be queuing for a while to get through security. and you're also queuing to get a cup of coffee, which is the worst thing to do at 7 o'clock in the morning. The other option is the 8-hour drive from Perth directly to site. You're mainly travelling on the Great Northern Highway as far as Woburn, and then from Woburn you're pretty much shooting a straight north bearing through Pindar up to Bellardi. The road from Perth to Woburn is the primary heavy haulage route for all the mine sites in the north of Western Australia. So it is literally, you are passing a lot of road trains carrying mining equipment back and forward between Perth and the mine sites. Lots of road trains. In this map on the right-hand side there, I've just shown you where the World Heritage listed Shark Bay is. As you can see, it's pretty much on the same latitude as the MRO. So for those of you that perhaps may know where Shark Bay is, just draw a roughly 500-kilometre line directly east and you'll cross the MRO. Driving is how we get most of our smaller freight items to site. And by smaller freight, I mean it can literally fit on a flatbed truck. It's cheaper for us to take our own freight that's anything less than a semi-trailer up to site via the drive rather than paying a commercial freight company. Freight companies just simply don't go out that way, so it costs you more to get freight to site via a commercial freight company. So site tempo, excuse me. The photos show the Bellardi accommodation facility. The top photo shows the sleeping accommodation and the bottom photo shows the grassed area in front of the communal mess. The timings are very simple. Breakfast is at 6, on the road by 7, on site by 7:30, depart site anywhere between 4:30 in the afternoon and 5:30. Return to site half an hour later, and then it's dinner between 6 and 7, and then wash, rinse and repeat for the next day. Having said that, it is weather dependent. So if it rains, you spend the day at Bellardi because the road will be closed and you just have to wait it out. But the other extreme of weather is the heat and the humidity. So this graph on the left-hand side there shows the ambient temperatures from a simple temperature monitor I've got hung up in the shade of a tree. It covers roughly 10 days. So the first, say, 2/3 of it, the left-hand side 2/3 shows most of last week, and the right-hand 1/3 shows the temperatures this week. Last week was extremely hot. And we had some humidity creeping in. This week we've had lots of storms, and the photo on the right-hand side there shows an afternoon storm creeping in over AAVS. That high temperatures and high humidity has meant that I've changed the tempo I'm working this week. And so for most of this week I was starting work at 5 and finishing it between 12 and 1. It was just simply too physically challenging to be out there in the high temperatures and high humidities in the afternoon, particularly when you're out there working on the ground planes and on the antennas. They are incredibly hot to the touch. And for those of you that are interested, that photo there is the dip in the graph. Not sure if I can't highlight it, but that rather strong dip in the graph on the 8th to the 12th is the storm coming in over the site. And as you can see, temperatures literally drop 20 degrees. And that's one of the important things that you do need to be aware of on site is the effect of the changes in environment can have on you. 1 minute you can be covered in sweat, stinking hot, wrapped in flies, and the next minute temperature will drop, or next hour temperature will drop 20 degrees, it'll rain, and all of a sudden you'll be freezing, you'll be literally shaking from the cold, and you need to get out of that environment because the body just simply can't stand those sudden changes. You do need to take care of yourself out on site. So the first major broad area of activities we cover is repairs. Repairs. The Murchison environment is not a great environment to install and operate electronic equipment, and it does suffer quite a bit. As you can see there on the top right-hand side, that's the first indication we have. We've got a problem in one of the MWA tiles. Obviously, we start getting a poor band shape RF signal from that tile, which indicates we've got a maintenance fault there. Some of the common and maintenance faults we're experiencing at the moment is this cable jacket degradation in the cables between the dipoles and the beamformers. My screwdriver there is pointing to some of the problems there. It's simply that the cable is just degrading. These cables have been in that environment now for 9 years, and it's a tough environment for them to be out in. So when we start seeing some of that poor RF signal and band shape coming through, where I am focusing my attention on the LNA and the cable because they're the two most likely suspects at the moment. The next major area which crosses over repairs is upgrades. As you can see in the top left-hand corner photo there, we've got a tile that's been sort of looking a bit sad. The cables between the dipoles and the beamformers have come loose of their securing cable ties to the ground plane, and we've got a little bit of silt and dirt sort of starting to cover over the ground plane. When the cables become loose from their ground plane anchoring, they flap around in the wind, and surface winds are constant on the MRO. It doesn't matter what time of the day or night, there'll always be a surface breeze. It may be quite weak, but it generally does become quite strong in the morning and in the afternoon. What that breeze does is it grabs hold of the LNA cables and flaps them around in the wind, and that's when the cable ties, which are naturally weak after being out there for so long, they break, and then the cable runs against the last strong anchor point. And you can see that in that middle photo at the bottom there, the cable is rubbed against the tie and has the jacket has degraded and exposed the braid. So this process of installing new beamformers, you've probably heard me talk about, or Dave Emmerich talk about the removal of some of the obsolete parts that have failed on the beamformers and upgrading those components. We're using this as an opportunity to inspect all the LNA cables and the ground planes. Some of the ground planes are quite rusted out, and we're replacing them as we find them whenever we install these new upgraded beamformers. This whole process involves looping all the LNA cables back to their dipoles, inspecting every cable. We've got to replace the ground plane. We lift all the antennas off, put a new ground plane down, reinstall the antennas, reattach the ground plane, reattach all the cable anchor points. It's quite a lengthy process, takes about 4 hours, even longer for some of the worser tiles. The next broad area we focus on is infrastructure management and monitoring. These three photos show some of the infrastructure on site. The left photo shows the cable trays recently installed to try and protect our fibre optic cables leading to the AAVS sites, as well as the power cables that lead to the AAVS sites. It gets the cables off the ground, which is important for something I'll discuss later in this presentation. The second, or the middle photo there, shows the remote processing facility, which will come into action hopefully next year, and will really help support the validation of the antenna design for the SKA. The top right photo there shows the housing, the shed housing for our high voltage on-site transformer. That is an important critical piece of equipment. Without that, nothing works. So once a year, we shut down the site for important electrical safety maintenance, and that is inspected and tested and recertified for another 12 months so that we can continue operations safely, knowing that that's going to hopefully keep working. So that's part of the electrical safety that we do. We've also got during that week, all the solar panel tile batteries are tested for resistance levels, and we monitor those to make sure that they're not increasing too rapidly. All our tagging occurs of our electrical instruments so that we try and get on top of anything that may occur, any faults that may occur in that 1 week when we do the shutdown. During that week, we've also got our one of our biannual physical safety audits happen. So things like fire extinguishers are all tested and checked. I just review the safety plans, make sure that everything is happening okay. We also then look at our environmental safety, things like our evacuation routes, what we're going to do in this, if we're told to evacuate, what we do in the event of fire, just some tabletop planning. Mostly occurs in my head, but it's a good little refresher for me, just to basically manage people and equipment and activities on site. Part of our monitoring, this is just one aspect of it, is we're supplying some temperature data to the SKA low team in order to support their validation of the antenna design. So the black line there shows the data from a temperature monitoring facility inside the container. The orange line shows the ambient mean temperature outside, and then the Goldie line shows the mean of 6 temperature loggers inside those cable trays. And we're just supplying this data to SKA Low so they can have an appreciation of the temperature environment of some of their equipment and their cables when they're installed on site. So we're doing this, and we're also monitoring and recording all our faults in order to provide input into the reliability of the final antenna design. Before I touch on site management, there's one aspect of site activities which I haven't discussed, and that's external instruments. So this year coming up, we've got 3 external instruments being installed on site. Prior to them getting to site, there's a fair bit of planning that goes on, and I would encourage anyone that's considering putting an external instrument on site is really reach out through the director to the operations team to get in contact with us very early in your design and in the shape of what you want to do. Power on site is limited, fibre optic access is limited, coax is limited, everything is limited. If you have an appreciation of those limitations early, it will help you in the reliability of your design later. Anyway, another broad aspect of our site activities is site management. The Murchison area is home to, it's a very unique environment, very large environment, but it's home to some fairly unique animals and plants. That photo on the left there is Steve coming in for a drink. Absolutely scared the crap out of me when he ran over my boot trying to get a drink of water. But it was a pretty hot day, and the MRO has had below average rainfall now for 3 years, so I can understand why he was a bit thirsty. So whenever I'm traveling around site, I'm constantly trying to aware of how we're impacting on the environment and try and limit that impact as much as possible. The photo on the right there shows one of my key areas that I'm always focusing on, which is the damage, not the damage, but the impact our cables have on the environment. This cable here on the right is being dragged by rain flows, And then the surface winds have contributed to the cavitation effect or the erosion, cavitation erosion of the water. And then what happens then is you get another rain event. It increases the erosion effect from water cavitation this time, and then you have wind cavitation and so on and so forth. So whenever I'm traveling around on site, I try and just move the cables and keep them moving so that try and limit the effect of wind cavitation. In front of that, so on, how can I say, the forward edge of this cable, you can see the effects of both wind and water cavitation. It's exposed the hard pan underneath the loose gravel surface of the ground. No vegetation will grow in there. So by removing the cable, it allows the loose dirt to come back across the top. That loose dirt contains seeds for future vegetation growth. So just try and limit the impact that we have on this environment so that when we finally do pick up the antenna and leave, we've left it in the best possible state that it can be. So that's the conclusion to the presentation. We covered those areas. If you do have any questions, please feel free to reach out through the operations email address. I'm always happy to answer any questions, and thank you for your time.
Thank you, Andy, even though you can't hear me. I'm sure we can probably try and answer any questions as well. So if you have any, feel free to pop them in the chat or ask away. Is that you, Clancy? Yeah, go for it.
Yep. Again, one of these comments, I'm going to use this as an excuse to thank Andy for all his help. This is coming from an external instrument hat on. You know, we started talking to the MWA ops people probably about 2.5 years ago or so about the cosmic rays experiment. So that was sort of a very long lead time, and that's been absolutely invaluable in helping us. So if you're thinking about doing something external, then these guys are an amazing group of people to, you know, work with. So don't think of it as some people who will obstruct you and try to stop you from doing your thing. Look at it as some free help. That's been great. So cheers.
Well, the cosmic ray experiment has been a huge success story, and we've been very happy to work with you, Clancy, on that. So thank you. Any other questions or comments? Okay. We can move on to Phil, and he's very nervous, so give him some support.
Lots of heckling.
Yeah. No. Where are we? Here we go. All right, take it away.
So I'm good to just start.
Yep.
Oh. Hello everyone, I'm Phil Gish, and I've been acting as the MWA's electronic repair technician since being employed here in March this year. I have taken on the role of servicing much of the MWA's electronic equipment and getting it back into service as quickly as possible. With thousands of pieces of equipment on site requiring repair and support across our 256 tiles and their associated receivers and support equipment, there is always a steady stream of equipment that requires regular disassembly and repair due to damage, degradation, or for general maintenance and upgrades. The largest single project I've been involved in since beginning my position here at the MWA is the beamformer upgrade project. This involves the upgrade of all 256 beamformers currently in the field, even the 128 that aren't currently connected to the system. The objective of this project is to extend the lifespan of these beamformers, replace components that have now been made end of life or obsolete by their manufacturers, and to bring the reliability of all our beamformers up to an equivalent standard. it has taken the work of multiple ops teams members to undertake this project, most notably Andrew McPhail and David Emmerich and myself. We've currently completed 90, so we're approaching the halfway mark. I've got another 30 that hope to be completed by January, and we're expecting to complete the whole 256 by the end of next year. Although Andy's already gone through some of this, the swapping out of beamformers from site and their transport to and from Perth is not an easy or quick task, and has been led by Andy McPhail. Requires shutting down power to the tile that requires its beamformer removed, transporting all the replacement parts and equipment to that tile, which is quite difficult, particularly with the long baseline tiles, which aren't necessarily along a short track. Individually removing all the 32 SMA cables from the front and placing them on the new beamformer, and then transferring the rain shield and grounding wires and other systems. And as you saw from Andy, fixing a lot of faults that may already be existing on the tile, such as shorted cables or other things that may either stop the beamformer from working properly or may in fact damage the beamformer. A single failed channel on a beamformer will ensure that the entire beamformer has to be shipped back to Perth for repair, and with this type of project, we do not want to do that. Once in Perth, the beamformer is disassembled. As you can see in the slides, there are only 3 different types of circuit boards. However, there is a second delay line board, as you can see in the first picture there. Each of these delay line boards takes the 16 channels from the tile, combines them. Also in the box is the beamformer dock that you can see at the bottom left of the second picture, the CPLD board, which controls the pointing of the antenna, transmits the pointing commands to the delay line board. The disassembly of this board is mainly taken up by the removal of the large numbers of fixings involved in these, with 20 case screws and 32 SMA nuts, washers and other bits for every single channel you have to disconnect from the board. And as you can see from the placemat sized board that we're dealing with, if you have to fix one part, you have to remove a lot of screws and other parts to get to it. Once the delay boards are removed from the chassis, we can remove the last of the lock washers because they will be damaged when we send them off to repair. Pack all of this in anti-static bags and then bubble wrap them and ship them off to a contractor who has access to a pick and place machine and a few better tools than we do at the MWA. And he will replace multiple different components on the boards. The main components that we are getting replaced are in essence all the amplifiers on the board. They are currently all end of life or obsolete. We can no longer reliably get spares for these from their manufacturers. All 16 amplifiers are replaced, along with the summing amplifier and the output amplifier. The input amplifiers are the 16 along the front of the delay line board, summing amplifier at the back, and the output amplifier, also known as U230, is the one just before the output for the delay line boards. Due to changes in design between the original components and the manufacturer's recommended replacement, certain component values had to change. And in the case of the output amplifier, an external daughter board had to be fitted. All the development and R&D work for this was done by David Emmerich, and quite an insane amount of work to get the new designs to work in pretty much exactly the same fashion as the older components did. Once these are brought back from, Upon returning from where we work, many passive and powered tests are conducted in order to confirm functionality. Each delay board will have 40 separate resistance checks to confirm there are no shorted components or bad solder joints from the rework process. This also checks for any components not covered in the upgrade, such as inductors that may have been shorted or partially shorted or opened by lightning strikes or other shorted SMAs that may have happened in the field. Once this stage is completed, the board has all the fixings attached, and including most notably the 16 SMA washers, and it's reinstalled into the beamformer chassis so that it can so that further testing, most notably the voltage testing, can then begin. Once installed and powered on, once installed and powered on, we can do our initial voltage testing, checking the supply rails at 5 volts and 48 volts are present, and that correct voltages are present on all the different amplifiers. If it does not meet any of these requirements, we automatically shut it down in order to make sure there isn't any damage that is caused, and further troubleshooting and other systems will begin to rectify those faults. Otherwise, we can then begin testing the voltages on each of the SMA input connectors. This is now done with our new LNA and voltage and current tester that you can see at the bottom on the left-hand side. This allows us to measure the voltage on the antenna SMA connectors under load without having to have a multimeter or bias T and other setup. It also has the ability to plug in SMA cables and LNAs into the back of it. So while we're testing in the field for shorts and other problems and opens in the antennas and their connectors, we'll be able to see differences in current and voltage, and thus hopefully more quickly identify faults with those systems. Once that is all done, we can place the beamformer in our little on-bench test rig and test the delay line functions. With power applied, we can now connect our spectrum analyzer through the receiver dock card there on the bottom right of the when we do this with PowerFlow, if all is going as planned, we should be able to see a trace on our spectrum analyzer similar to the one you see on the left there. This is a good signal through our system. It is a bit jumpy rather than the normal curve you'll see in a normal plot from one of the receivers or our systems. That's because of a few impedance matches within our test setup. This does not affect the functionality of the test because we're looking for differences or significant spike differences or changes that would be different from a good working beamformer to a failed one. If that all passes, then we go into our VNA tests with our vector network analyzer. The output is connected through a bias T. The output from the vector network analyzer is connected through a bias T to the input of the beamformer, and then the output is fed from the receiver dock into the input of the vector network analyzer. Vector network analyzer. The result should look like a video on the right here, if I can just start it up. Okay. With the channels, once it's connected up, we start switching sending pointing commands through. This changes the delays present, in this case, just between one of the 5 delay lines that are in there on the delay line board. You'll see it basically doubling in amplitude each time the settings are changed. If all of these pass, then we do it for the next channel and the next channel. Total, we've got total of, again, 80 readings in order to ensure that all channels, there's no distortion on the gain or the delay that will affect any of the readings you're receiving. Once that all is completed, we can do the same again for the XPOL, the top delay line board, and install that into the beamformer. And once that's all completed, we can seal the box up and place it on one of our new soak testers. This runs the system for 48 hours. It sends close to 50,000 pointing commands or more, depending on how quickly you send them, to fully test the communications of the beamformer. All the SMA connectors, so edge channel, is loaded down with a 50 ohm terminator to run the system under full load. And we measure the current draw to make sure that it's all within parameters we're expecting. Once all this is completed, we then repeat all our spectrum analyzer, voltage, and vector network analyzer tests again. And then once that's all done, we can finally ship this beamformer back to site, usually with Andy on the back of a truck. Some of the general faults we'll see, here's a few examples that you'll see in the field. That the first one is showing extreme distortion in both gain and delay. This is quite often caused by one of the summing transformers at the back that combines the 16 channels into one, having failed. The second one's a lower gain and it quite often can be caused by multiple different things, from leaking RF switches to a failed inductor on the input drawing, or a shorted inductor or an open inductor drawing things down, cracked capacitors in the delay line tray, that particular delay line. But these are relatively easy to find, easy to see, and are always fixed before they're shipped into the field. Now, this is one of the more complex and annoying faults we've had at the MWA this year. The beamformer RF comb. This was seen, as you can see from the plot on the left, on a couple of our receivers. This managed to slip through all our testing and work, despite our best efforts. The reason for this is in pretty much all cases, it didn't exist as a fault when it left our test facility. As you can see, you've got about 12 to 15 megahertz spikes across the spectrum from, well, in this case, you'll see on the spectrum between 0 and 300 megahertz, and on our actual spectrum analyzer tests across up into the gigahertz range. This was caused by microfractures in the daughter board capacitor. So this was a rather unique and, well, I'll call interesting fault, in that the components tested perfectly well in the field, before they entered the field. But due to the way that the daughter board was designed, it's a very thin daughter board, about 0.5 millimeter in thickness. The depanelizing process, when they were snapping the boards out of the frame, and when we were getting these remanufactured, and the capacitor's position, as you can see, it's stretched lengthways across the board, meant that it could be affected by stress and other things when it was first installed into the system, causing tiny fractures. Now, if there was a temperature shift, movement, such as being transported up to site, any further rework or other systems, it could exacerbate that fault. And it would slowly increase cracks, change the movement, and as you can see with this little with the little video, would cause a fracture to occur in the capacitor and to expand it.
How long did that take to diagnose?
To diagnose wasn't it. Finding all the reasons for it was the other thing is you could physically switch those combs on and off by applying force to that daughter board. So it would you could basically touch it with the end of a plastic pencil and it would fix the problem quite happily. And in some cases you couldn't get it to refault after that, despite what you did to it. In other cases you could cause it with the same kind of fault. But yes, it was a very, a very frustrating fault. Now, as you can see, we have done significant changes to our daughter boards and our designs in order to fix this. The original version you see on your left, there's also the circuit diagram of what we're doing. The actual daughter board has changed a bit in its electrical design. We've removed an inductor from the circuit because it allowed us to get a bit more gain out of the amplifier. But also in order to try and reduce these cracks from ever happening, we've substituted our general purpose ceramic 0603 MLCC capacitors with flex terms, which are more rated for hostile environments and are less likely to fracture. And all the existing original boards have now had their capacitors replaced with the flex term capacitors. The upgraded version, as you can see, we've moved the capacitor so that it's will no longer be flexed when it's snapped out lengthways across the board. And so far, we haven't seen any faults or any cracks from the new delay line boards. Now they've been shipped out to site. What else have they got? Finally, one of the more interesting faults I'm finding at the moment, and boards coming back to us, is our 60 dB spike that we're generating between about 0 and 100 megahertz. That's annoyingly only observed when you've actually sealed up the beamformer ready to be shipped out. So this is usually found in the last tests once it's all been assembled. We've tracked it down to where it's being caused. It's being caused again in the output amplifier and in the little daughter board that's attached to it. It's not caused by any component failure or any other general fault. It's caused, from what we can tell, by the exact positioning of the amplifier on the board and how flat and secure it is to the actual grounding plane and other connections it is on the board. As heating it up and doing rework and ensuring it's basically perfectly pressed against the board will remove that spike. But if it's seen there, it's usually radiating in and out, radiating that spike noise throughout the entire beamformer chassis. So you'll usually see one amplifier is radiating it, and that will be the reading you'll see on the other amplifier that's receiving it. And if you just cover that amplifier with a little metal RF shield, it'll completely disappear. But we didn't want to make that huge modification to every single one. So we've just found that ensuring that the amplifier IC is correctly positioned and secured does remove that fault. So thanks for that. That's the end of the, oh, sorry, some feedback here. That's the end of how the faults and the issues we've had with the beamformer upgrade. Are there any questions?
I would, yeah. I hope we've yeah. So Miguel's made a comment. So Miguel, great talk. Thanks so much for all this work. Thank you, Miguel. All right. right.
Thank you all.
I hope we've given everyone some input to the usually invisible operations that happen behind the scenes from all these hardworking people, both on site and.
Oh, that's it.
Can I ask one?
Okay.
Sorry.
I mean, like Mia said, it's an incredible amount of hard work that goes into making all these things work. But my query was, you mentioned that now the all 256 beamformers are now upgraded, a lot of new components and things like that. So obviously they are going to be a lot more robust. But in terms of like resilience to the weather issues or lightning and other kind of sorts, are they going to be like more tolerant than how things have been in the past?
Unfortunately, no. These are basically a direct one-to-one replacement for the existing components. The only way we'd be able to do more tolerance is a complete redesign of the beamformer boards, and that's not really up on the scale at the moment. It should improve reliability because, again, lightning. Many of these beamformers have been in the field for 8 or so years now, and lightning damage and accumulative damage, particularly to the front end amplifiers on the delay line boards, are pretty common because it's quite easy to get lightning coming down an SMA cable from an antenna. And by doing this, we've basically reset the clock on all that. But yeah, there's still a lot of, unfortunately, they're still susceptible to lightning, the same as all our other, our previous beamformer setup as it is now, unfortunately. We still haven't found a great solution for solving lightning problems.
Thanks, Phil, and thanks to you and the whole operations team for keep things going with the array. Thank you.
It's been a huge team effort.
You've got lots of thanks there, Phil. Thanks from Randall. You've got thanks from Divya. So, all good.
Star of the show.
Oh.
All right, I've got your slides here, Melanie. I think this is the last talk.
Yep. All right, this is probably going to be the least coherent talk that I've ever given that I wrote it in parts in Ubers and while doing other things, including being interviewed on TV in the break. So this is my reflection of 9 years in the MWA, and when I was thinking about this morning, I think it's really a tale of two correlators. So it starts and ends with a correlator. So I'm just going to go through how I got into the MWA, what I did in the MWA, and some of the lessons that I have taken from my time in the MWA. And I should say, for those of you who don't know me, I have, in addition to my time on the MWA, spent time also working on LOFAR and the SKA. So quite a long time on the SKA in both of those projects in very different roles. So in a very junior role on LOFAR, but in the SKA, it was very much a sort of the science and governance high level strategic role for New Zealand. So how do I make this thing advance? Oh, I have to click it twice. All right, so we're going to start with a quote from June. The beginning is a very delicate time. June, for those of you who don't know me, is my favorite book ever by Frank Herbert. You should all read it. It's not really sci-fi. It's a tale of the last 2,000 years of human societal evolution. But anyway, the beginning for me of the MWA, I've said that it starts mid-2011, but it doesn't really. The first interactions that I had with the MWA was I signed up to a mailing list for a science group sort of MWA thing. I don't really remember what it was, but I think Stu was in charge of it. The name of the book is June by Frank Herbert.
Oh yeah, June.
With a D. June, Sand Dune. Dune. Anyway. Thank you. Okay, so it is a great book. It's a fantastic book. I love it. Anyway, my first encounter with the MWA was in 2007, and I signed up to some sort of MWA science group, and I think Stu was in charge of the MWA Science Council at the time. And someone who shall remain nameless said to me, you don't want to get involved in the MWA. That project's going nowhere and it's not going to amount to anything. And so I won't tell you who that was. I don't think the same person who's still around would actually say that now. So I kind of had that in the back of my mind, but in mid-2011, I was at the SKA Forum in Assen in the Netherlands, and I was there right in the middle of the Australia-New Zealand site bid to host the SKA. So I was on the foundation board for the SKA at that stage. We hadn't constituted the proper board. And New Zealand had put up $500,000 for groups in New Zealand to somehow get involved in something that was related to SKA and the path to SKA. And I was sitting at the bar, as you do, and Stephen Tingay sat down and we started drinking. And I explained to Stephen that there was this $500,000 and I wasn't quite sure what to do with it. And Stephen at that stage had recently become the MWA director and had got some funding together to build most of the telescope, with the exception of it didn't have a correlator. And Stephen said to me, "You're not interested in the MWA, are you?" And I said, "I don't know, maybe." And we continued to talk about it over the course of the meeting in Assen and decided that that might be a good thing for New Zealand to get involved in. And Stephen's plan was to have New Zealand use that money to provide a correlator. And so that's the path that we went down. Now, it was extraordinarily quick. So 6 weeks later, there was a full proposal for an IBM shared university research grant and a proposal that went into the Ministry of Economic Development in New Zealand for their $500,000. And I had got a $522,000 contribution from my institution, VW. Now, the way that that all transpired is I went back to New Zealand and I was in an SKA group with a guy called Dougal Watt, who was the chief technologist for IBM New Zealand. And Dougal said, "IBM would like to support you in this. And you can go through this shared university research grant process." And we did that, and it was super quick. And they gave us 7 nodes of the 24-node IBM iDataplex system, which is currently our correlator. And the rest of it they gave to me at a very cheap price, which I'm not allowed to actually say, but heavily discounted. But the speed was astonishing. So IBM Australia and New Zealand and the US supported this. And the New Zealand government didn't give me the whole $500,000. They gave me $400,000, and from that we got a correlator. So by December, so 6 months later, I was at the MWA board meeting in Melbourne, and there is a picture from the MWA board meeting in Melbourne, which was my first board meeting precisely 9 years ago, in 2011, and put together this proposal, which was roughly about $2 million worth of stuff in the end, for New Zealand to have that be their contribution to join the MWA. And the board approved that, and that was my entry into the MWA. Now I'm going to zoom in on this photo because there are some regular faces there. So that's me, if you can't tell. Yes, people come up and have a look. I don't think I look that different, but there's Dave Emery. Dave does not look that different. No, Dave hasn't changed. There's Stu, our illustrious chair of the board. Stephen, of course. Tom, Buller, Randall, and Ramesh. Oh my God. Goodness. Yeah. Wow. Anyway, so Tom in particular, I'm kind of...
Are you sure that's Tom?
I'm pretty sure that's Tom. Anyway, so that was 2011 December.
Brian
so precisely. Yeah, Brian in the back. Yeah, and Ben McKinley, and Natasha's there. There's a whole bunch of people. So Miguel looks the same. So yeah, there you go. So that was my first MWA meeting, and I went with my DVCR, and we had a formal signing ceremony. So at that stage, MWA was just Australia, New Zealand, and India, and so there were only 11 institutional members, and so New Zealand was actually the 4th member country to join, and VW was the 12th partner institution. And at the time, there was 116 individual collaboration members. So that's where MWA, that was the scale of MWA when I got involved. As I said, this correlator was super quick. It was delivered in January 2012 to Curtin, and Brian and Steve Ord and other people cobbled it together and made it work. And I should say that in that 6 months late, in the later part of 2011, Randall got the fun joy of working out how to make what IBM was offering as hardware suitable as a correlator. And so this was very much a, what are we going to get for this price? How do we make it work? Let's put this system together. So that's the process that we had, and that got us to phase 1 of the MWA, which was declared functionally open in 2012. And that's one of the pictures that I took from the opening. So Stephen, as then director, talking to the assembled masses of dignitaries on site. Yep, this was all up on site. That was good because like the SKA board got to actually fly up. The MWA board got to fly up too, so I got to fly, which is good. So yeah, science commissioning was completed relatively quickly, mid-2013. So really quite fast and a very different process. So I stayed on the board as New Zealand's member, and then in 2013 I became vice chair of the board. And I remember that my job was to throw people off the builders list. So we had a builders list. The board had decided that it needed a refresh, and they needed someone to write to all the people who were being refreshed. And I got that job. So that was my first axing job, which I happily volunteered to do, which I think probably most people wouldn't be surprised by. And then for the next 4 years, I chaired the board. And so what I did there was, I think, mostly governance. So phase 1 to phase 2, and looking at how you put that together. How does a project like the MWA run? So that's a very different role to what I had now as director. So by 2015, we'd increased to 16 partner institutions over the 4 countries. That was via the addition of ASU and Washington and other ones in the States. And I agreed in 2013 to host the MWA project meeting. So this is actually December 2013 in New Zealand. This is not the project meeting itself. This is the EOR breakout busy day thing. And you can see me and my postdoc Luke Heinsohn looking really confused and bored there on the left. Not that you're boring, Miguel. I'm sure what it was fascinating, but we weren't really up to it. And so, yeah, that was the EOR group. This was working with Stephen. So Stephen was the MWA director up until 2015. And so as director, I worked with him quite closely as chair of the board. This was actually a visit by the Honourable Stephen Joyce, Minister for Science and Innovation from New Zealand, to Curtin. So Stephen Joyce was actually in Perth for something else, and said he wanted to come out and talk about MWA since New Zealand was a member, and SKA since New Zealand was also involved in that. And Stephen called me and said, can you get on a plane and come and speak to your minister in Perth? And so I did that. So that's me and Stephen in 2014 in our respective roles of director and chair of the board. So I think the most substantive thing I did in the governance, and I'm not going to go through all this in detail, was the transition from phase 1 to phase 2 and then later to phase 3. This was setting the sort of tone for that. So really it was a lot of work getting people on board to get money and how that works and the definition of a quantum. And so at the time we sent out some letters to partner institutions, or I sent them out asking what they wanted to put in for a possible phase 2 of the MWA. And Stephen put in a LEAF grant to get $1 million to actually pay for the upgrade path. And so there were 2 routes to actually put in funding to MWA at that stage. So one was to contribute through the LEAF grant that Curtin submitted, or through direct cash contributions. So Australian, New Zealand and Canadian institutions actually put money in through the LEAF, and the US through direct contributions. So I'm not going to go through the details of what it all looks like. You can, if you really want to know how the governance structure works and why it went that way, feel free to ask me later. But this was the table from the LEAF grant. So just showing the money that people put in. So Stephen was the PI for this, and various people from different institutions and partner organisations were on the LEAF grant. There were 15 people on it, and that was successful for $1 million. That's just a letter that I got from Miguel when I was chair of the board in 2015, talking about the US's desire to be a part of the MWA going forward and what they would contribute. And this is the letter that I got from Brian in the same capacity, saying what Canada, the University of Toronto, would put into the LEAF grant to be as part of MWA phase 2 and phase 3. So that's mostly what I did when I was chair of the board, that sort of thing. And China and Japan. So China and Japan came into the MWA project a bit later on. So Japan in 2017, and it was actually Rachel Webster that pointed the Japanese towards the MWA, and then I did the negotiations with Kitaro. China, I hired Kathy Shang as a postdoc, and I got to go and visit China in 2013, and through Kathy and others and many visits to China, we developed a relationship that eventually resulted in China signing up to be part of the MWA in 2017 for phase 2, with a contribution of $1 million Australian in cash over 3 years. And so that's actually, again, that's the MWA board meeting in December 2017. And that's the last meeting I had as chair of the board. And that's Xiao Yu. And we're shaking hands because we signed this MOU. And I don't know what I've done with a piece of paper. I hope I gave it to Mia to archive. I gave it to someone. Mia's shaking her head. This is bad because I moved it out of my office. But anyway, I'll find it later. Anyway, so that's the then board members and others at the time. Oh yeah, and I got to have this very serious looking photo with the Chinese delegation. And this includes very senior officials from the Ministry of Science and Technology in China who were supporting China's entry to the MWA, as well as Xiao Yu and Shan Ping. All right, those are the people who are at the project meeting. Again, you can try and sort of see regular faces. I didn't put circles around these ones. We don't look that different, I think, in 2017 as we do. I said 15 before, but this is 17. This is December 2017. I don't think we look that different. But yeah, so similar cast of people. There's Kathy and Stephen and all sorts of people. Xiao Yu, of course. All right. All of this resulted in a collaboration agreement. And this has been extraordinarily useful for me professionally. And again, I'm not going to go through it, but we are using this model that I came up with for the collaboration agreement and the idea of quanta for other partnerships, which Curtin is now doing with industry and so forth. So this has actually been a model which has been tried and tested through the MWA and is now being applied elsewhere, where you kind of have tiered memberships with different amounts of money that get you different things. All right. So MWA in phase 2. So I told you at the start of this talk that in 2011, when I got involved, we had 3 countries, 11 institutions, and 116 individual members. Right now, in phase 2, when we started phase 2, we signed the collaboration agreement a year ago, we had 6 countries, although New Zealand has since departed. We had 20 to 21 institutions, so 21 when New Zealand is in, and 20 now, and of the order of 270 individual collaboration members. So that tells you that the size of the collaboration in terms of the user base and the institutions involved has effectively doubled in that time period. So it's not the project it was when I got involved. And I did also want to say that was sort of on the MWA side in terms of governance. This is my research group in New Zealand in 2015, who were largely using the MWA to do research, not Steve Curran, for those of you who know him. He was sort of doing extra stuff. But you can see Luke in the middle and Kathy to the bottom right, who are now involved in the MWA and other areas as our principal scientist and as a board member at the moment. So that's Kathy when she was a postdoc working in my group, and Luke was actually a research assistant. So Luke is an undergrad in that picture. So yeah. All right. So that's sort of governance stuff that I did for the MWA was not very different, I don't think, to what I was doing for SKA on the SKA board. But it's an interesting thing to sit on different sides of the table. So being on a board and doing the sort of strategic oversight and the putting together of the collaboration, how that works, is very different to sitting on the other side and being the director and having to be substantially responsible for running an instrument and making sure the budget's right and that, you know, the resourcing is matched to the ambition and things like that. And so I had not done that before. So coming to be MWA director in January 2018 was something new for me. And it was Stephen that organised for that. So Stephen, as I mentioned, finished being MWA director at the end of 2015. Then Randall was director. And then they needed a new director in 2018, and Stephen organised for me to be able to do that. And I was wanting to leave New Zealand for reasons I'm not going to go into, but it was good to be able to come home. And so I hadn't done any operations before. First thing I got to do was have the phase 2 MWA launch. So this is me with the VC of Curtin and 2 of the ministers here in Australia at the phase 2 MWA launch, which was very successful and a big PR event and fantastic. But what I want to say about this is I was not responsible for phase 2 getting up and running. That was really Randall. So my favorite picture from the phase 2 launch is actually this picture of Randall and I. because it was really, I think, the work of Randall as director, supported by me as chair of the board, that allowed phase 2 to happen. So it was me pressing the button because I'd taken over the role of director, but it was really thanks to Randall that the operational side of that happened. Okay, so this brings me to what I kind of want to talk about being director and what I've learnt. So this was the MWA org chart as of January 2018 when I took on the role. So that's 4.9 FTEs if you add up all the management and all the people in the operations team. And you know, you've already seen the punchline of this is that from my talk this morning, it doesn't look like that anymore. This was supported by $1.32 million per annum in MWA funding from Australia, largely. And that was the funding level that had been allocated in 2013 at the commencement of operations when Stephen was director, and it hadn't been indexed. So that level of funding wasn't even really enough to pay for those people, plus Curtin pays the director's salary. So one of the first things that I did was change it. So that's what it looks like as of November. So we're up to 1.495 million from MWA per annum. We've also now got 2-year MWA funding rolling instead of 1 year, which previously we'd have to sign a variation to contract again and again and again every year. Incredibly annoying. It also doesn't provide for staff stability. And that 1.95 million, the reason that I successfully argued for that to be increased was the ASVO. So a pilot study had been done for the ASVO under Randall's tenure as director, and that had been very successful. And AL was keen to see that continue to operate and be utilised by the MWA collaboration and to be incorporated into the definition of the observatory. And initially, the suggestion was that we could do that with the budget that we had, and my suggestion was that we couldn't. And so if they wanted that to happen and the definition of the observatory to change, then they had to put the budget up in order to be able to appoint someone who could look after it, which is Harry, who we now have. Yeah, no worries. And in addition to that, through some other efforts, we managed to also hire Phil, or Andy first, and then Phil and Harry and Ricky. So that was the way that worked. So Ricky was actually funded from some residual ADAX funding, which now that I'm the director of the Curtin Institute for Computation, ADAX actually sits under me, but so I wouldn't give it to MWA now, but Andrew Roll did give it to us. Sorry, guys, I have something to do with it here. So anyway, and then there's the 284K that came from the Oz SRC, which has allowed us to hire DoIT. Plus the phase 2 partner contributions. So the scale of the operation is larger, both in terms of the institutions, in terms of what constitutes the telescope, and in terms of what is needed to run it. So it's now 8.3 FTE, or it was as of November. And I think that's the biggest change that I see in the way that the MWA works, is that there's this increase in the scale of the operation and what it does and what can be provided and how that's done. So as I said, the ASVO and the long-term archive are now in the definition of the observatory. The ASVO is maintained by Harry as a dedicated ops team member, which is included in the MWA funding budget. The long-term archive is still provided by Pawsey, and we are reliant on Pawsey to continue to provide that. So one thing that I flag is that the close relationship with Pawsey needs to be maintained and curated. I kind of want to talk about this slide that I brought up this morning. And this talks about how MWA does things now. So, as I said, this is a tale of two correlators. It started with a correlator that within 6 weeks we had a proposal for funding. We got the funding. The hardware was on the ground 6 months later. A correlator just happened magically. And the process that we've been through now, where it's taken 18 months to get the funding, we've been through multiple documentation processes and design processes and you know, as I said this morning, CDR. So this is the timeline for MWACS. We didn't have a timeline for this for the first correlator. It just kind of happened. And so all of these checks and balances are good, and they are commensurate, I think, with the evolution of the MWA to be a more professional and substantive and internationally renowned observatory. But I flag that if I go back, and I don't know how to go back. How do I go back? This one. Oh God, we're going forward. This is still only 8.3 FTEs. And this is a group of people that is running a fully operational radio telescope. They're doing, you know, keeping it going. You've heard from Phil how the maintenance works. You've heard from others how it is to keep things up and running on site. So this is still a very limited resource. And it's not the level of something like CSIRO or Astron or the SKA. So when I was on SKA, we went through a critical design review. We had months to write the documentation. An enormous team of people wrote the CDR documentation for the CSP, for the correlator, with a technology stamp in 2016 for a machine that's not yet built. So whether or not that will be useful, I don't know, but that's a different scale. And so I think it's good to realize that telescopes come from the scale that MWA was at the start, which is just bolt it together with whatever you've got, however you can, to that scale of sort of NRAO, you know, SKA, where you've got teams of people doing project management and writing documentation and so forth. And I think MWA sits in the middle, and it's important to keep in mind where it sits in the middle. That, I think, is the challenge for the MWA project that I take away from having sat on both sides of that table as chair of the board and then also as director. So I'm not going to talk about this process again, but just to highlight that. So yeah, so this group of people though that did MWACS, again, with the exception of Brian and Ian, who have kind of been pulled in from the Curtin engineering team, the rest of those people are in that 8.3 FTE. So they have day jobs to do. They have things to run. And so, yeah, I just really want to emphasize that they've done an outstanding job, but you can't get blood out of a stone. So you just have to keep that in mind. So, yeah, so my time in the MWA over the last 9 years has kind of suggested to me that the MWA it's not the same. The scale has increased in all dimensions, not just the telescope, but the number of people, the institutions, the stakeholders, the complexity, the investment, the interest. And these are all good things. These are all good things. It's good that the MWA is achieving this level of success. And yet it's still a very lean operation and run on a shoestring. So the challenge is to ensure that the ambition of the project doesn't exceed the level of resources. And so that's the message I kind of want to pass on to the MWA as we go forward. So do keep that in mind. So these guys here in this picture and the people sitting around me in the room, they are fantastically good at their jobs, and I could not have wished for a better team, honestly. But their resource is finite. And secondly, being small and agile and flexible is an advantage. So if I look back on the things where the MWA has pushed through and has got stuff done, where I've seen many larger and better funded projects stall and not move, it's because of that agility and that flexibility and the ability to respond to things quickly without being bogged down in process and regulation. And that's a philosophy. And so that's a challenge for people running the project and going forward to consider. What is the philosophy of the MWA? What is the scale of the ambition? If the ambition exceeds the resourcing, how is more resourcing going to come in? What's it going to look like? Comes back to Mia's point about, you know, not running meetings if you don't need to run meetings, and not asking for documentation you can't actually act on, and not asking for information to be collected when there's no mechanism for you to use it effectively. Those are all things that I think the MWA teaches you well and should be kept in mind. So the last thing that I want to say about my time in the MWA over the last 9 years is that many people have contributed to the success of the MWA. And it's not just the visible people. It's not just the people that we see here in these meetings. It's not just the people whose faces appear in the media or who are visible and loud. It's the legal team at Curtin. So Claire and Aoife, who went above and beyond to help me write the collaboration agreement. It's the people who in the press offices and our partner institutions who help put out our press releases. It's the funding agency staff who work with us to get funding grants through and approvals through and to help us. And so the MWA, I think, is a success and a shared triumph. So the success of this project really is a shared triumph. And each and every one of the members of the collaboration who've contributed to the MWA, be that through science or through operations or through management, should rightly feel proud of, I think, what has been achieved, because it has been astonishing from the advice that I got back in 2007 of don't touch that because it's going to go nowhere. So I think I would like to sort of say that if anyone says the MWA was really driven by one person or, you know, a very small number of people, then that's a disservice to everybody who's been involved. And my personal thanks goes out to each and every person that I have worked with over the last 9 years to make this a success. It's largely been one of the least painful projects I've been involved in, with a few exceptions. But yeah, I think it's been great, and I wish you all and all of these partner and associated stakeholder institutions every success in continuing to take it forward. And I look forward to see what will happen with phase 3 as you go forward into 2021. So thank you. And you can ask me questions if you like. Or we could just go back to the picture of like people looking young and try and work out who they are.
I still look young.
Thank you, Ivy. All right. Well, if no one has any comments or questions, we have a lunch to go to. No. All right. Well, good luck, people. See ya.
Thank you, everyone.